welcome to Vedantu NEET English. I'm Diksha, your chemistry master teacher. How are you all? Everybody join in because today we are going to do structure of atom, where we are going to complete the chapter. The whole chapter we are going to complete structure of atom. From the very basic, we are going to start from discovery of electrons to quantum numbers, electronic configuration. All the concepts where the questions are asked. I am going to cover everything today itself. So everyone join in, everyone in the chat box. Am I visible? Am I visible to all of you? Am I visible? Am I audible? Yes, everyone. Okay. Let us wait for students to join in. Guys, this is going to be a very important session because in this in the whole chemistry we talk about atoms, right? If you don't know what is the structure of atoms, right, then how you will be able to grasp the other concepts here. So for structure of atom, I am going to cover the PYQs as well, and I am going to cover the important formulas here. Okay, everything will be covered here in detail with a very crisp twist, right? Okay, everyone? Yes. Okay, let's join in the session. And yes, students who are, thank you so much for being so concerned about me. That's so sweet of you. Actually, what happened because of cervical issues, cervical spondylitis I have. Because of that, now my arm, this right arm, is not working properly, but for that I'm taking physiotherapy sessions, and so don't worry, I'll recover soon. But your study, I'm trying my best, right? I'm trying my best not to obstruct your studies in between, right? So that is why we are going to take the lecture as we have done previously as well. But yes, I'll use less of this arm and more of this arm, right? Okay. Yes, everyone. Very good evening. Very good evening. Very good evening. Okay. So there are lots of things that we are going to cover today. You might feel that, okay, ma'am, why ma'am is writing like this? Why ma'am is using this hand? Right? Because ma'am, this arm is not working that much. Right? That's the reason. Okay? Yes. Yes, don't worry, I am fine to take the lecture. Like, I am trying my best not to write that much on the board, so that I use less of this arm and I use more of this arm, because this arm is totally fine, but this arm is having issues and this neck is having issues. So I hope so in 10 to 15 days, maybe 1 month, I'll be fine. But yeah, the more I move my arm, more it will be, in the working phase, because if I do there's a lot of spasm and stiffness on my neck, so that's the reason. So yes, okay, yes, my health is fine now, don't worry. Whenever I'll feel that I need some rest, I'll surely give you break and take rest for 2-3 minutes or 5 minutes. Okay, that works for you all. Okay, whenever I will feel that, okay, I'm feeling little dizzy and I'm feeling little uncomfortable with this, I'll give you some question. You solve that question. Lots of question I have for you. PYQs I have for you. You solve those questions. I'll take the break in between. Yes, bacha? Okay. Thank you, bacha. Thank you so much. Thank you so much. Ma'am, ambidextrous. I don't know what is ambidextrous. Is this a symptom? Is this like some sort of disease? No, I have cervical spondylitis. Nothing more than that. Yes, thank God. This will recover. This will be recovered. Thank God I picked up like early. But this because this is, I would like to give you a lesson on this. Just 2 minutes I'll take for you. Like what I used to do 10 years back when I was of your age, I gave my exam in 2014. I gave my 12th exam. That time what I used to do, I used to lie down and study. Right? I used to study like this. So because of that habit, I developed this cervical on my neck and I ignored that. Okay, I used to do headstands and yoga and all that. Now what happened, because of that, this got really severe cervical. And after that, I met with an accident and that led to this, weakness of the tendons of my bones. So that is the reason sometimes when I'm not eating healthy, I'm not taking care of myself, this happens. So always take care of yourself, right? That's the advice that I would give you, because don't be another Diksha, right? In terms of this cervical thing, just take care of your health, because once you lose this is very difficult to recover, right? Okay. No, I can't write with both my hands. I will write like this. Don't worry, you will see I will be able to write, okay? Yes? Okay, yes, bacha? Okay. So let us start, bacha. You can expect anything from you, right? Okay, just focus on studies and you will be able to crack anything, right? So let us start the lecture starting from the theories. The first part here is Dalton's atomic theory. So what happened when we used to know about the matter? Matter is made up of very small particles, that is atom, and that atom means indivisible. Okay, Dalton's atomic theory states that atom is indivisible. But after the discovery of subatomic particles, that are electrons, protons and neutrons, this theory got neglected, and now we know that this theory was first proposed by scientist John Dalton, and he proposed as regarding ultimate matter. Okay, this is the tiniest particle, this is the fundamental unit. But after this theory got rejected, we know that today atom is not indivisible. Atom is made up of electrons, protons, neutrons. So today firstly we are going to see how these were discovered. Okay, so firstly let us see Dalton's atomic theory postulates. First postulate is matter is made up of small indivisible particles, that are atom. Second postulate is that mass can neither be created nor be destroyed. Okay, it changes from one to another. That means mass of reactants is equals to mass of products, right? That means atom, we cannot just generate an atom. Atom is just converted to one thing to another thing, right? That means one atom is converted to 2-3 other atoms. We can generate one more atom in this universe. Okay, that is what this is saying. Third, we have atom is the smallest particle, right? Nothing is smallest. Dalton used to say this, but now we know that there are more things that are smaller to atom, right? Next is that atoms of same element are identical. Okay, atoms of same element are identical, like hydrogen. You carry hydrogen from anything. In any compound, hydrogen will have same, that is completely identical, right? Okay. So atoms of different elements are different masses. So now these things have exceptions now, right? Fifth and sixth points are also exceptions now. Now how? After the discovery of isotopes, isobars, these 2 points are neglected now. It is saying atoms of different elements. For example, I have different elements. They are going to have different mass shape. But now we know that potassium and calcium, they are different elements but they have same mass, right? So that means this point is neglected here. Next is atoms of different elements combine in a wait, this is now fourth point this was for isotopes, right? And this was atoms of same element are identical. But now we know isotopes. We know that isotopes, we have different isotopes of hydrogen where the mass is not same. The atom is same but the mass is not same. That is also against this theory, right? Again we have atoms of different element combined. This is what? This is nothing but that we studied in some basic concepts of chemistry, that is fixed proportion. Like if you take water from anywhere, water will always have this formula, that is H2O, right? This is what they are saying in the sixth postulate here, right? Okay, next bacha, we have failure of Dalton atomic theory. So now let us understand why it got failure. Because of the isotopes, isobars that we have. Atoms are indivisible. No, it is divisible. It has subatomic particle like electrons, protons, neutrons, right? That is why it got rejected. Next thing is, what are the subatomic particles and how they are discovered? For that we are going to do the discovery of electrons and protons. Very simple thing that I am going to teach you here. That is, if you talk about H2 is going to give us this, right? This is H2, right? This, if we break this hydrogen, you will get, after the breakage of this thing, if you break this H2, what you will get? You will get one H positive and you will get one electron, right? You will get one H positive and you will get one electron. This is what you are going to get here. So he is saying that if we talk about two rays, that is cathode rays and anode rays. Cathode rays are nothing but rays of the electrons. They are called cathode rays, right? And what is anode rays? Anode rays are nothing but they are rays of the cationic part. I am not saying proton, I am saying the cationic part of any gas. Any gas, the cationic part is the anode rays. The combination of cationic part is the anode rays, not the proton. Only in case of hydrogen, we say the cation is proton itself. But in case of lithium and any other atom, the cation is not the proton, right? If you talk about any other atom except for hydrogen, the proton is not the cationic part. That is why I say in case of anode rays are never called the combination, the rays of proton. They are not the rays of proton. They are cations. Anode rays are cations. Cathode rays are electrons. Yes, bacha? Bacha, it is better now. It is better now, right? Yes, don't worry. It is better now. Yes? Thank you, bacha. Thank you, Bala. Thank you. Okay, understood this? This is anode. This is cathode. Now, next, let us see the discovery. For discovery, this is the diagram, okay? Now, what we are going to see here? It is we have one cathode and one is anode. Cathode is always the negative electrode. In this case, we are talking about cathode is the negative electron and anode is the positive electron. This is connected to the negative part. This is connected to the positive part of the battery. So now this is high voltage. If we talk about high voltage, what does this mean? High voltage, why we use high voltage? Because if we use the high voltage, it will be very easy to ionize that atom. This atom will be ionized very easily, okay? This atom will be ionized very easily. So what we need to do, we want to ionize that atom to get the electrons and the cations, right? Okay, that is why we use high voltage and low pressure, because we don't want so many atoms there. We want atoms to, we want to see the movement of what we get from the ionization of the atom and see the movement. For that, we are going to use vacuum pump to lower down the pressure here, okay? There will be vacuum here. Now, this is called the discharge tube. So, very important. Cathode rays move from cathode side. They are not emitted. Note this point, bacha, very important point, because I am not able to write everything on the board now, right? That is why you have to do this adjustment, that whatever I am speaking, write it down, okay? Write it down, because of my arm issue, I am not able to write everything on the board. But yes, I am trying my best, whatever I can write, but whatever I am speaking, note it down, okay? Electrons are not emitted from the cathode. They are not emitted from the cathode. They are coming from the cathode side. They are coming from the cathode side. They are not emitted from the cathode. Okay? It is not a part of cathode. It is a part of the atom, right? Cathode rays, that is the collection of electrons. They are emitted from the, for example, here we have one atom. The atom will be split into one cation part, right? That is one H positive and one electron. Right? This electron is moving from this charge. Now, how do we define that this is an electron? Why we define that this is a negative charge? Because this is coming to positive charge, that is why it is a negative charge. Right? That is why we say it is coming towards this. First thing is high pressure, then we have low pressure. Third thing is what are cathode rays? That are the electrons, the collection of electrons is called cathode rays. Now, let us see. This is all, he applied high electron voltage to gas at a very low pressure, right? Let us see some points of cathode rays, very important points. Now now we know the structure of atom, right? We know the electron in any atom is going to be the same, but the cation of any atom is not the same. That is why cathode rays depend on the cathode rays do not depend on the nature of the gas, because electrons do not depend on the nature of the gas. Electron's mass is fixed, but the mass of cation is not fixed, and cation is nothing but anode rays, right? Okay, so now let us understand this. The flow of current from cathode to anode was further making, okay, so now let us see this, how it was discovered. Okay, there are 2-3 more points to it. Now this is the anode, this is the cathode, right? We can't see electrons, so how we saw that these electrons are moving? Okay, there was a ZNS screen here. Okay, there was a ZNS screen here which used to glow when there is any electrical charge here. Okay, so it used to glow whenever there is striking of any charge here, any charge particle here. Okay, so and also we made the anode, we made the anode perforated here. Perforated means we put a hole in the anode so that there is, for example, the electrons are coming from this side. The electrons are coming, right? Okay, if there is one slide here, okay, if there is one any kind of barrier in this side, okay, in that case the electrons is not able to move. But here we have the ZNS screen, so for that we need to pass a hole, we need to make a hole in anode, that is called perforated anode, right? Okay, all the points? Yes. Now let us see the qualities of cathode rays. They move from cathode and move towards anode. They rays are themselves not visible, but how we see this? We see this which glows. We see this when they glow on striking with the ZNS screen, that is fluorescent screen. Next, in the absence of, very important, in the absence of electrical and magnetic field, these rays travel in straight line. Okay, in the absence of electrical and magnetic field. But in the presence of electrical and magnetic field, they behave same as a negative particle should behave, right? Okay, next is the characteristics of cathode ray does not depend on the material. They do not depend on the nature of gas. For any gas, we use any gas, there will be same. The answer will be same. For any gas, electrons is going to be same. Okay, the rays are going to be same, right? Okay, yes, beta. Okay. Now, next we have, okay. Now let us see few things here. Let us see few things here. Okay. I think it is written here. Right. Then I should not write it, right? If it is already written here. Or I should. Okay. This is E. This is electron. This is proton. This is neutron. These are the three particles here, right? These are the three particles. Electron, protons and neutrons, right? So, one thing that you must know is the charges on them. Okay, what is the charge on electron? The absolute charge is going to be 1.6 into 10 raised to power minus 19 coulomb, negative. The charge on proton is 1.6 into 10 raised to power minus 19 coulomb. The charge on neutron is going to be nothing. Neutron is have no charge, right? And absolute charge is going to be minus 1, plus 1 and this again 0. What about the mass, everyone? What about the mass? The mass is going to be here we have 9.1 into 10 raised to power minus 31 kilogram. This is 1.67 into 10 raised to power minus 27 kilograms. This is 1.67 into 10 raised to power minus 27 kilograms. Okay, do take care of the units here. Okay, okay, bacha. Yes. Next we have, these are the charges, these are the masses. Next we have the E by M ratio. Okay, this is the charge, this is the mass, this is the charge, this is the charge. Okay, so E by M ratio, we can say this is the E. Okay, this is the charge here. E by M ratio is nothing but the ratio of this over this. Okay, this is the ratio. So ratio of E by M ratio, E by M ratio of electrons come out to be this much. If you divide this, the ratio comes out to be 1.75 into 10 raised to power 11 coulomb per kg. Right, this is the E by M ratio, that if you divide this. Right, okay. Also very important thing here, if we talk about the E by M ratio here, right, E by M ratio here. This is for proton, this is for electron. E by M ratio of electron is, electron is independent of the nature of gas. That means E by M ratio will be independent of the nature of gas. Okay, it will be independent of the nature of gas. Independent of nature of gas. Independent of gas. Okay, this is dependent on gas. This is depend on gas. This depend on gas. Okay, this is the first thing. Second thing here that we are going to do, this does not have E by M ratio is equals to 0 because charge is 0 here. Right? Next thing, bacha, that we are going to talk about here is, you have E by M ratio. Okay? If we talk about the E by M ratio, here, see this very carefully. If we talk about the E by M ratio here, what we are going to see here, if we increase the voltage, if voltage is increased, or we can say E by M ratio is inversely proportional to the voltage, right? In the discharge tube, you have voltage, right? If that voltage increases, E by M ratio decreases, right? What does this mean? Now, we all know that E by M ratio, here we use moving mass, okay? Here we use the moving mass. This is equals to rest mass divided by 1 minus V by C square, right? Now see this. If voltage is increased, if voltage is very high, the electrons are going to increase the speed. The velocity is going to be more, right? If voltage increases, velocity increases. If velocity increases, this whole thing, this will decrease, right? This is going to decrease because this is going to increase. This is going to increase. So this whole thing is going to decrease. In that case, this is going to increase. If this is going to increase, this is going to decrease. Now, if voltage increases, velocity increases, this whole thing decreases. If this decreases, this increases. If this increases, this is E by M, so this will decrease, right? Okay? Yes, that is why we say E by M is, if we talk about electron or proton, in both cases, it is inversely proportional to the voltage here. Yes, bacha. Okay, understood this. E by M ratio is inversely proportional to the voltage. Yes, everyone, understood this? Yes. Okay. Any problem here? Any problem? Next, see. Next, what we are going to do here. Next, we have, this is again E, this is P, and this is N. Now, if we talk about, or we can just ignore this thing, okay, or we can write this. If we compare this with 1 AMU, if we compare this with 1 atomic mass, this will be electron mass is equals to 1 by 837 times of 1 AMU. Okay, this is 1 by 837 times 1 AMU. This is equals to 1 AMU. This is also almost equals to 1 AMU. That is the mass of the hydrogen. So from here we can say, mass of electron is equals to 1 by 837 mass of protons or neutrons. Mass of proton. Understood this, bacha? Any problem? All these values are very important for you, right? All these values are very important. The add alpha particles, yes, I am going to add that. Just wait, yeah? Okay, we are going to discuss alpha, beta, gamma, everything. Next is, now this is not asked in your exams, that is Millikan drop experiment. So this experiment is E by M ratio, right? How experimentally it was calculated, basically how this charge on the electron was calculated, okay? This measures the mass of the electron, right? Mass of the electron by using cathode ray tube, by applying electrical and magnetic field perpendicular to each other as well as the path of electrons. Here that was here we calculated the mass of the electrons. Mass of the electrons were calculated by Thomson here, right? And the charge was calculated by Millikan drop experiment. Just this thing is asked to you, that how charge were calculated, what experiment was used to calculate the charge. That was Millikan drop experiment, and mass was calculated by J.J. Thomson applying the electrical and magnetic field perpendicular to each other. Right? Okay, these two experiments were done. Okay, in this experiment, what they took the atomizer. Okay, this is the atomizer from where oil drops were spread here. Right? And at this point, here you have this telescope from where you saw the oil drop here. But at one point, this oil drop is going to be static because of few forces here. Okay, let us understand how it was discussed. X-ray, this is for the source of electron. Right, this is from the source of electron. There is a small drop for the movement of the oil drop here. For the movement of the oil drop here, right? But the oil drop, and this is the sheet. This sheet is the positive sheet, right? This sheet is the positive, and here we have the negative electrons. Okay, and here at one point, what you will see, the oil drop is static. Why the oil drop is static here? Because of two opposing forces, that is electrical field and gravity. Electric field is opposing upwards and gravity is downwards. That is why we saw the oil drop is static, because we can see the oil drop, we can see the electron, right? We can see the oil drop. So because of this experiment, after doing the calculation from this experiment, the charge on the electron was calculated, right? And the charge on the proton was positive of the charge of electron, right? This was the whole thing, right? Or by measuring the rate of fall of these droplets, Millikan was able to measure the mass of the droplets, right? Okay, all these things were taken here, right? Okay, bacha? Yes. So this was the Millikan oil drop experiment, not much in detail in your syllabus, right? Okay, next we are going to do the charge on the electron. We have done that. Now let us come to the questions here. The ratio of charge to mass of an electron in coulombs per gram was determined by J.J. Thomson. He determined the ratio by measuring the deflection of cathode rays in electromagnetic. What value did he find for this ratio? They are talking about the ratio, the E by M ratio here. What is the E by M ratio, bacha? What is the E by M ratio here? What is the... See this is in grams, okay? This is in grams, not in kilograms, okay? This is in grams, okay? What is the A, B, C, D? What is the correct answer? For electron, E by M ratio is going to be, bacha, everyone, this is minus 1.76 in 10 raised to power 8. This is for gram. For kilogram, that would be 10 raised to power 11. See the units here, okay? Always see the units here. Next, we are going to do, that is discovery of proton. Discovery of proton is exactly same. In this case, we just use two things different. That is, here anode is the cations. Okay, it is a collection of cation. These are anode rays. Second thing, here we used, okay, here in this case, the rays were emitted from the anode side to the cathode side. That is why we have to use the perforated cathode. Okay, here we use a perforated cathode and the ZNS screen was applied on this side. Okay, here we could show the ZNS screen and this was applied to this. Okay, here we see the electrons are passing from the positive cation is passing from these holes. Right? Always, this is the most confusing thing that students do. Anodes are not protons. Only in case of hydrogen atom that you will see anodes are protons, right? Because H positive is proton. H positive is proton. Otherwise, anode rays are the collection of cations, not protons. Okay, they are not the collection of protons here. Yes, bacha. Any problem till now? Any problem? So anode rays are also called canal rays. Okay, they are also called canal rays. The stream of particle is called anode or canal rays, which consist of positively charged particles called protons. Okay, those cations are positively charged particles, and only for hydrogen atom, that cation is called proton. He made the cathode perforated to observe the anode ray. Right? Okay, so these were the observations. Unlike cathode rays, mass of positively charged depends on the nature of gas. Why it does depend on the nature of the gas? Because cation, if we talk about lithium atom, we talk about any other gas. If I am talking about nitrogen gas, in that case, nitrogen, the cation of nitrogen is going to be the anode ray particle here. That means it depends on the nature of the gas, right? Okay. Yes, bacha, because we know nitrogen is 7, it is going to have 7 protons here. If we talk about the nitrogen again, the cation of the nitrogen, when it loses electrons, it loses the electrons. In that case, what you will see, this is the cation, this is not proton, right? The charge to mass ratio, right, of the particle depends on the nature of gas. We saw that E/m ratio of proton depends on the nature of gas. Next is positively charged particles carries a multiple of fundamental unit. That is what we did just now. That if we talk about oxygen, oxygen has 8 electrons, 8 protons, right? Oxygen has 8 protons in it. That is a multiple of fundamental particle. And that fundamental particle is known as proton. Yes, bacha? Okay, this is the major controversy. Who discovered proton, Goldstein or Rutherford? This is the most confusing question, because there are so many books that is written Rutherford and so many books that is written Goldstein. But actually what happened while this experiment was done, when this experiment was doing, in this case, usually what scientists believe, okay, some scientists believe that it was discovered by Goldstein, some believe that it was discovered by Rutherford, right? You have to follow that is written, which is written in your NCERT, right? You have to follow that thing. But otherwise, in reality, Goldstein discovered the cationic part, right? Goldstein discovered the cationic part, that there is some cationic part. In case of hydrogen, we have that cationic part, and he didn't name it. He didn't name it. Okay. After the discovery, after the Rutherford model, it was discovered that there are some protons. That is the fundamental particle, right? So that is the exact confusion, because here cationic part was discovered. But some books they have written in NCERT also, I guess it is written Goldstein, right? Okay, but in competitive exams, I think Rutherford is the right answer in competitive exams of SCSC, SSC and other IAS competitive exams. I'm not sure about it, but yes. But this is the major confusion. But the reality is cationic part was discovered by Goldstein, and in case of hydrogen atom, that cationic part is proton, right? But the clarity was given by Rutherford, right? Okay. Yes, bacha, understood this? Yes. Okay, now let us talk about the smallest lightest positive obtained from hydrogen. See this, the smallest and lightest positive ion was obtained from hydrogen, and that was called proton. That they are talking about H positive here. They are talking about H positive in this case. That was called the proton, right? Okay, yes. Now let us talk about alpha, beta and gamma particles. Okay, let us talk about the alpha, beta and gamma particles here. Firstly, I will give you some brief theory about it. Then my arm will also get rest in between. Right, then we will study the theory part. Okay. Now let us talk about alpha. Let us talk about alpha. Alpha is what? Alpha is what, bacha? Alpha is the nucleus of helium. What is helium? Helium is this, okay? It has 2 protons, it has 2 neutrons, it has 2 electrons. But if we talk about helium-2 positive, that is the alpha particle. That is alpha particle. That means it has 2 protons, 2 neutrons, no electron. It does not have any electron. It does not have any electron. And it is a large particle. It is a big particle. It is a big particle. As compared to big particle, as compared to beta and gamma, the size is much more, right? Second thing is, it is positively charged. It is so positively charged, it does not have any electron. So the tendency to gain electron is very high. That is why it has very high ionizing power. It has very high ionizing power. The ionizing power is very high, okay? The speed is very slow. Speed is very slow. Speed slow. You will say, oh my god, speed is very slow. We can we can move fast in comparison to alpha particle, but no, that is not the answer. Okay, its speed is approximately equals to 10 raised to power 7. But no, that is this speed. You will say, ma'am, this is such a large term, 10 raised to power 7. Right, but in case of beta and in case of gamma, the speed is slow. right? In case of beta and gamma, the speed is slow. So this is about the alpha particles here. This is about the alpha particles here. Now let us talk about the beta particles. Let us talk about the beta particles here. Okay, let us talk about the beta particles. So about the beta particles, okay, nothing but electron. But you will see if you study it in detail, I think in physics you will be able to study beta particles in detail, right? In radioactivity, you do study it in detail. These are basically two. We have electron and we have positron, right? But we usually consider electron here, okay? So here I am going to talk about electron only, okay? Here we are going to talk about electron only, which has mass approximately equals to approximately negligible mass. We consider the mass is very less, approximately negligible, but the charge here is negative. Okay, then let us talk about the gamma particles. What about the gamma particles? Nothing, useless, not useless, but yeah, it does not have anything, right? Why? No mass. It has no mass. It has no charge. It has no charge. Okay, it has no mass, it has no charge, but the speed is very high. It has maximum speed. Now if I compare this, if I make this easy for you, if we talk about the speed or if I talk about the penetrating power, so more is the speed, more is the penetrating power, right? Okay, so if we talk about the speed and penetrating power, okay, that is that penetrating power, gamma, then beta, then you have alpha. So this question is asked to you. The speed of gamma particle is the maximum. The penetrating power of the gamma particle is the maximum. Okay? Yes, bacha? Yes, bacha? Done? Okay, good. Now, next let us go through the theory part. Okay? Now, I have made you understand everything. I have taught you everything regarding alpha, beta and gamma that is asked in your syllabus. Now let us go through this. There exist three major types of radiations that are emitted by radioactive particles: alpha, beta and gamma. Talking about alpha, it is the nucleus of the helium atom, that is 2 protons, 2 neutrons, no electrons. Right? So positively charged particles, they have two neutrons and protons, and the penetrating power is very less here. Highest ionization power, they are able to ionize anything. Okay, if they get electron, if you pass some atom, they will abstract out the electron from that atom. That is the ionization power of this. They are capable of ionizing numerous atoms by short distance. Just need to go side by them, they will abstract the electrons from that atom. Right? The ionizing power is very high. Next is beta particles are extremely energetic electrons that liberated from the inner nucleus. Now, ma'am, what is this? Now, what is this inner nucleus thing? Now, what do you mean by this? Now, let us see this, okay? Let us see this. If we talk about the atom, we all know how an atom is made. This is the nucleus, these are the electrons, okay? These are the electrons, these are the nucleus. Now, we know that in nucleus, we have proton and neutrons, right? Whenever the proton is getting converted into electron. See this, what is this? What does this mean? When a proton is getting converted into electron, it releases few particles, right? And the particle here, one of the particle is beta. One of the particle is beta particle. And how you will see this? Okay, I'll make it easy for you. Okay, I'll make it little easy for you. Yes, see this. Okay, you have this proton. Everybody, proton, the mass is +1. Okay, the mass is +1. The charge is +1, and the mass is here. We say 1, right? Okay. And if we talk about the electron here, the charge is going to be almost negligible. The mass is negligible. This is -1, right? And now you have this beta particle. Wait. This is +1, -1. There is 1. No, 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 done something wrong here. So, wait. This is actually related to radioactivity. This is the nucleus plus we have proton and neutron. This proton is having zero mass. Wait, just give me a minute, okay? This is having zero mass. This is having zero charge. This is having same mass, right? Having same mass, and this proton is having plus one charge, and this is having mass as same, right? And if we convert this into electron, this is going to be one charge here. This is going to, the mass is going to be almost negligible, but the charge is going to be negative here, right? And thus it will need one more particle that is having positive charge, and the mass here is, I think there are few particles in this. I can't remember those particles because they were in the radioactivity, right? You just need to remember this one thing. When proton is getting converted into electron, converted into electron, this is from the inner nucleus that is happening. This is the nucleus, right? In the inner nucleus, the proton is getting converted into electron, and that is how we say there is release of beta particle in the internal nucleus, because in the internal the proton particle is getting converted into the electron particle, and there are various other particles, radioactive particles, that are released side by side. I don't remember what are the three particles were released side by side. I can't clearly remember what was that, but that is in your physics, I guess. Yes? Okay? Okay, bacha? Yes. Now, next we have, I think that is in this, yeah? Okay? Yes. Now, if we talk about this is the example I was looking for. Okay, so we have this thorium. Now, this is getting converted into platinum. Now, what we took here? It took one electron here with mass 0 and charge -1. So this was actually the conversion of this proton to this electron. That is why we say this is from the inner nucleus, right? Okay, next thing that we have here, okay, next thing, they bear negligible mass, carry negative charge. A neutron in the nucleus splits into proton and electron on emission of beta particle, right? Okay, the nucleus splits into proton and electron on emission of beta particle. When the beta particle is emitted, that nucleus is split. That is why it is from the nucleus, right? Okay, then beta particles have higher penetration power as compared to the alpha particles, and the maximum is gamma particles, right? Talking about the gamma particle, they have highest power of penetration here, they have highest speed, they have least ionizing power because they are neutral, no mass, no charge, nothing. Very difficult to resist them from entering the body because they have very high speed, they are very penetrating, okay, right? The gamma rays carry a large amount of energy and can also travel via thick concrete and thin lead. They can travel through anything because they have very high penetrating power, right? So questions are asked from the penetrating power, the ionizing power, okay? These two questions are asked from alpha, beta and gamma rays in chemistry, okay? So these are the symbols and these are the composition, 2 protons, neutrons. It is electrons, high energy. This is no charge, no mass, right? +2, -1 and this is 0. Yes, beta? Perfect. Now, next we have discovery of neutrons. Discovery of neutrons were given by Chadwick, and here what he did, he bombarded the helium on the beryllium, right? Helium, I am saying, he bombarded the alpha particles. He bombarded the beryllium by alpha particles, okay? Here I will write the alpha particles, okay? Here, alpha particles were bombarded on the beryllium and hence we got the neutron. This was converted into carbon-12 isotope and we got this neutron which has no, this particle was firstly discovered and then we thought that nucleus is very dense, it has very high charge. And always remember this experiment, okay, this in Rutherford model there was no discussion about the neutron. Okay, in Rutherford model, we used to think that nucleus has only protons, right? But after the Rutherford model, we knew that, okay, nucleus is very dense. Okay, nucleus is very dense. So it must have some another atom also which is making it so much dense, and that another atom was neutron, which did not have any charge but it had only mass. Yes, okay. Next bacha, these are the charges, the masses that we have done, okay, before I have made the table for you, and E by M ratio. Now let us do the atomic models. We have, firstly we will do the Thomson model, very simple. Then we will jump to the Rutherford model, which is important, the observations and conclusions. Then to the Bohr, the formulas of Bohr model are very important. The last model is going to be quantum mechanical model. Okay, yes bacha, okay, perfect. Next bacha, let us do this. Firstly, Thomson model of an atom. This is nothing but plum pudding model of watermelon. Just imagine a watermelon. The electrons, the black seeds are the electrons and the red part is the proton. Now, he said that protons are divided. It is like uniformly divided throughout the atom, right? And the electrons are embedded between the proton in the red part. Electrons are embedded like beads, like seeds of watermelon. But this got failed, right? This got failed because there is no stability. There is no stability of this model, right? This is plum pudding, raisin pudding or watermelon model. Very simple, no question is asked from this model, right? Next is Rutherford model. Now questions are asked from Rutherford model, right? Okay, let us see this. Now what he did, Rutherford, what he did, he said that this is the source of alpha particle. This is a lead source, okay, lead source of alpha particle. Here we will see the alpha particles. Now you know about alpha particles that they are highly positive. They will get attracted towards the negative thing. They have two positive charge. They are very highly positive. They have very high ionization power, right? They want to extract the electrons. So for that we are using the gold here, the very thin layer of gold here, right? The thin layer of gold is used here because gold is very malleable, most malleable metal, right? That is why gold is used here. So what is happening here? We have a hole, okay, for the lead plate where the hole was done, right? So that the rays is going straight towards the metal, right? This is the metal. The rays are going here, okay. Now there is deflection. There are three conditions. There are three observations that happened during the Rutherford experiment. So what was these? The zinc sulfide, okay, this is what? This is the zinc sulfide. We know that zinc sulfide is nothing but whenever anything strikes on the zinc sulfide or fluorescent screen, it glows. That determines, okay, there is some electron, there is some charge here, there is some charged particle here, right? So that is the use of ZNS screen, right? Okay, alpha particle used because they are relatively heavy, resulting in high momentum and very high ionization. Now, let us see the observations here. What he saw that 99% particles, alpha particles, because they are positive. If they see electrons there, they will get attracted towards it. Positive, negative attract each other. So 99% will go straight, undeflected. They will go straight. But now we know that nucleus, it has proton, right? It has positive charge. Alpha particle is positive, nucleus is positive. It is going to feel repulsions from that positive charge, and that is the reason. And this is the nucleus, this is going through this is going, and now it feels a repulsion. It will get deflected. So it's a few particles out of those, few alpha particles got deflected by some angle. They were going like this, they got deflected because of the positive charge on the nucleus. Now third thing what they saw, if there is some villain and you are just facing it, right? Okay, you're just moving, not moving here and there. You're just facing it face to face. What will happen? Okay, that bouncer will bounce you on the face, right? This is what happened here. Okay, this positive charge, this positively charged alpha particle faced this nucleus. Head-on collision was there, not actually collision. You won't say collision, I won't say collision, but yeah, you can imagine the head-on collision between two villains, right? What happened? It bounced it back, it gave a punch to it, bounced it back, it got deflected by 180 degree, totally got deflected, right? It bounced back. So this is just few, like 20 particles out of a million, just few got deflected back. So what are the conclusion that you draw from this? What are the conclusion that you draw from this? Let us see if there is any diagram here. No. Okay, so I'll make you understand here only. Right, the first conclusion that 99% particles were moving straight here. That means the electrons are moving in orbits and most of the space in the atom is empty. That is why 99.9% particles go straight forward. No deflection, nothing. Few alpha particles got deflected. That means there is positively charged nucleus on the center of that atom, right? That is very small. That is having very small size. And just 20 out of millions got bounced back. This means that nucleus is very, very small. Very small. You can imagine a cricket ground and the players in the center, Virat Kohli in the center. That Virat Kohli is the nucleus and the stadium is the atom, right? Nucleus is so, like, in comparison to stadium, nucleus is, Virat Kohli is very small, right? In comparison to that stadium, that big stadium, right? Okay, that is the difference between a nucleus and a atom. Nucleus has just very small space in the atom, but that is very dense. The whole mass of the atom lies on the nucleus. That means in nucleus, always remember this thing, Rutherford did not have any information about the neutron. He just knew about the protons and electrons, that electrons are revolving. He said electrons are revolving around the orbit and nucleus is in between. It is in the center. It is in the center. Right? Electrons are revolving around it. He said that. Okay, he did not talk anything about the neutron. But now today we know that nucleus is in the neutron. Today we know that. We did not know that earlier. Rutherford did not give any information about the neutron. Okay, he gave information about the proton. Okay, yes bacha, very good evening, very good evening. Okay, very good. Now, next is the conclusion that we have discussed. Most part is empty, heavily charged, positively charged nucleus, and that is very dense. Okay, in comparison to total volume, that is very heavy. Okay, that is very dense, right? Okay, if we say almost 10 raised to power minus 15 fraction of the whole nucleus. Okay, nucleus is 10 raised to power minus 15 fraction of atom. Okay, fraction of atom. Now this is compared to the solar system. This is also called the planetary model, that like sun is like we have sun in the center and planets are revolving around the sun, same way electrons are revolving around the nucleus, right? Okay, density concentrated extremely small region, small portion of atom was called nucleus by Rutherford, and very high speed. See, nucleus is surrounded by very electrons that move around the nucleus in the circular orbits in a very high speeds. Okay, always remember, Rutherford did not say orbital. Orbital thing was given by quantum model, right? He used orbits here. Okay, this was the orbits, right? Thus, Rutherford model of atom resembles solar system, that is planetary model. Electrons and nucleus are held together by electrostatic forces. Now, what is the explanation how they were held? He said by the positive and negative electrostatic forces it was held. Right? Next thing, bacha, that is the mass of, we say radius of atom. That is 10 raised to power minus 10 meter, and radius of nucleus is 10 raised to power minus 50 meter, right? Okay, if we talk about the radius of nucleus, the formula for this is directly proportional to a raised to power 1 by 3, where a is the radius of the gold foil atom, right? Okay, everyone. To be precise, I can write it as 1.4 into 10 raised to power minus 13 a 1 by 3. Okay. Now what is? I think yes, that is done. Yes, bacha? Okay, understood this? And this is very dense, and nucleus is very dense. Very dense, approximately 10 raised to power 13 times something. Okay, it is approximately 10 raised to power 13 times. Okay, or we can say nucleus is very dense. Nucleus is very dense and it did not give no information about neutron. Okay, Rutherford gave no information about the neutron here. Yes, bacha? Hello. Bacha, you need to increase your speaker because I am able to hear. Right? Okay? Yes. Now, bacha, next thing is limitations of Rutherford model. Limitations, bacha, it will take around 2 more hours because we are going to complete everything here, right? Okay? Yes, I think by 9 p.m. we will be finished. Okay, but we will not be finished. We will finish this chapter. Now that joke I know. Now limitations of Rutherford, right? What is the limitation? The biggest limitation of Rutherford was that according to Maxwell theory, if something, according to Maxwell theory, we say that electron is moving here. If something is moving with the changing velocity, why velocity is changing? Because at every instant the direction is changing. That means velocity is changing. There is accelerated. The body is accelerated because of change in velocity. Now for every body that is accelerated, it will lose energy in the form of radiations. That is the Maxwell's theory. That means this electron should lose energy. Right? And it should collapse. And the atom should collapse. But this does not happen. Right? This does not happen. The atom is very stable. So this theory got rejected here. Right? That is why this theory got rejected. Because of spiral motion falling into the nucleus. Because of Maxwell theory. This says that charged particle moving around oppositely charged center continuously loses the energy, but this does not happen. And also next thing is, if electron will continuously radiate, then spectra. Okay, atom is given line spectra. Wait. Okay, next is about the spectra, that if electron continuously radiate energy, then if spectra should be continuous, but this is not the case, right? There should be spectra, right? But this gives line spectra. Now, how do you define that? Why it gives line spectra? There is no information about it. How we are saying that this is giving the line spectra? This is actually stable, right? So for that, new model came, that was the Rutherford model. Before that, let us discuss the questions here. Which of the following observation was not correct according to Rutherford scattering experiment? Everyone, which is, yes, moving stationary orbits, right? That was given by Bohr. Now Bohr will come into picture and he will tell you that how we can say that electrons are revolving around the nucleus but they are stable. Okay? So, which of the following observations are not correct during Rutherford scattering experiment? Most of alpha particles pass through the gold foil undeflected. They just go undeflected. Most of the, yes, it is right. Okay, this is right. Next is the small fraction of alpha particles were deflected by small angles. This is also right. A large number of alpha particles bounced back. This is wrong. Very few particles out of 20,000, right, got deflected, bounced back here. This is wrong. Very few particles, 1 in 20,000 were bounced back here. So this is going to be the wrong answer. Wrong answer means the wrong statement. That means the correct answer here. Okay? Yes, very good. Next everyone, next we have what is mass number. How do you calculate this? Very simple thing, okay? Very simple thing. Let us see this. This is A. This is the atom, the element. This is A and this is Z. Now, what questions are asked from this? This is the mass number. That means, writing it here, this means this is neutrons plus protons. Okay? This is the atomic number. That means it is representing representing the protons here, right? It is representing the protons here, and this is the mass number. This is the mass number. This is representing the neutrons plus protons here. And always remember this, for a neutral atom, not for ionized, for neutral atom, electrons are equal to protons. Electrons are equal to protons. So if you're giving anything like this, you can calculate the mass number, atomic number, number of neutrons, number of protons, number of electrons. Yes, you can calculate everything from here. Next, bacha, let us see this. How many neutrons and protons are there in the following? Everyone here. We are going to calculate the protons here. These are the protons here, okay? The protons are these. All these are protons. This is having 6 protons. This is having 8 protons. This is having 12 protons. This is having 26 protons. This is having 38 protons. Okay, these are the protons. What about the neutrons? Neutrons is nothing but A minus Z, okay? A minus Z is going to be the number of neutrons here. Okay, that means N plus P minus P, that is neutrons here. Okay, so subtract this, 13 minus 6, 16 minus 8, 24 minus 12, 56 minus 26, 88 minus 38 is going to be the number of protons here. Number of neutrons here, that is A minus Z. Okay, bacha, understood this? Very simple, these questions are asked, okay? These questions are asked. The atomic number, mass number. If you have to calculate number of neutrons, that is A minus Z. How to calculate number of protons, that is Z. Okay? Yes, perfect. Now, next is isobars, isotopes, isostars, isodiaphers, isotones, then isoelectronic. So these are the 6 things that we are going to do today. Right? Very simple. You just need to see what are the formulas for this. What is the definition of this? Okay? I'm writing it down. So this is isobars. Then we have isotopes. Then we have isotones. Then we have isoelectronic. Then we have isostars. Then we have isodiaphers. Okay? Yes? See this here? For isobars, everybody in the comment section. Yes? For isobar, for B, bar, what is going to be the same? A is going to be same. That is atomic, that is mass number is going to be same here. Right? Mass number is going to be same. Z is going to be different. Isotopes are different. Isotopes are totally opposite to this. That means A is going to be, or you can say Z is going to be same and A is going to be different here. Right? If we talk about isotones, that means here we say, this is isotopes, that means N minus P. Isotones, we have, yeah, neutrons. Yeah. Neutrons are going to be same here. Okay, neutrons are going to be same. How do I remember this? Tones means when you are doing low down your tone. Okay, we say be neutral. Be neutral towards everyone. That means neutrons. And lower down your tone. That's it. Tone means neutrons. Tone, neutrons. Okay. Then electrons mean isoelectronic means number of electrons. Number of electrons is going to be same here. Okay. Number of electrons is going to be same here. Number of electrons is going to be same here. If we talk about isostars, in case number of electrons are going to be same and number of atoms are also going to be same here. Okay, number of atoms are also going to be same here, right? In case of diaphers, we have N minus P is going to be same. That means neutrons minus protons is going to be same here. Yes, bacha, everyone understood this? What is isobar? B, A for apple, B for ball. So we say B, A. A we have for A, we can say A is same. Okay, A is same. Next we have topes. Okay, for topes this is opposite to this. Okay, isotopes all know. Okay, isotopes are very easy, right? Okay, we have same atomic number. We have same atomic number. In that we talk all isotopes of carbon, oxygen. We all know the definition, right? Isotones, when we are taking lower down your tone, we say be neutral. Okay, so tone, neutrons. Electrons, that means iso means same. Okay, so electrons are going to be same. Stars means electrons and the number of atoms both are going to be same. Diaphers means, okay, diaphers means n minus p is going to be same here. Okay, also funny thing to learn diaphers here, that is diaper. Okay, so babies, when we put diapers, what they say? No, no, no. So we can say nope. What they say? Nope. So n minus p, right? Okay, very weird thing to remember this. Yes, bacha? Okay, perfect. Now, next thing, we have done all these things. Okay, you can go through the examples here. These are the examples of tones, right? The examples of tones, that means neutrons are going to be same. Okay, this fraction of this is going to be same, right? Next is electrons. So electrons are going to be same here. Okay, electrons we have same. This is a isoelectronic, right, bacha? Understood this? Okay, yes. Okay, now bacha, which of the following species is isoelectronic with CO? With carbon and oxygen. Carbon has how many electrons? Carbon has how many electrons? 6 electrons, and oxygen has 8 electrons. That means 14 electrons. So out of this, which has 14 electrons, this N2 has 14 electrons. So N2 is going to be the correct answer here. Yes, okay. This has, bacha, this has 6 electrons here, 8 electrons here. That means sums to be 14 electrons. And this has 14 electrons. So these are isoelectronic to each other. Next we have electron. Now we will move towards, we are moving towards a Bohr atomic model. So are you all ready for Bohr atomic model? Everybody in the chat box. So are you all ready for Bohr atomic model? Right? Okay. Yes. Very, very, very important model and question. Definitely you will see questions from Bohr atomic model. Sure, short questions are asked from Bohr atomic model. So now let us see Bohr atomic model. First is electromagnetic theory. Okay. So before starting the Bohr atomic model, let us go through the electromagnetic theory. So we know that there were so many discussions about the wave nature and the particle nature of a light, of an electron. So electron is also kind of like light is made up of photons, and photons are similar to electrons, right? Okay. So it was said that light has wave nature and particle nature both. There were experiments with justified wave nature. There were experiments with justified particle nature as well. So there were two things here, right? So let us first discover the electromagnetic radiations here, right? Okay, okay. Electromagnetic radiation, for two things that you need to know, that this is the, we talk about the wave nature here. Okay, we talk about the wave nature here. Firstly, we are talking about the wave nature here, right? Here we are going to talk about that if we talk about this, if this is the direction of, if let me because yeah, I think this will be much better for me to make it more comfortable, right? Okay. Now see this. This is going to be your, if this is the direction of propagation of wave, this is going to be your magnetic field and this is going to be your electric field. This is what they are saying. The direction of propagation of wave is perpendicular to magnetic field, is perpendicular to electric field. These three things are perpendicular to each other. You can see this. Okay, these three things are perpendicular to each other, right? Okay, so the radiation consists of electrical and magnetic field oscillating perpendicular to each other and perpendicular to the direction of propagation of light. This is electromagnetic radiation. Okay, so now let us talk about few more things about this, that what is wave number, what is lambda, what is time period. Okay, wavelength is this particular thing. Okay, one oscillation, the distance between two consecutive crests and troughs. Okay, this is the crest and this is the crest. So this, the distance from this to this side, this is the wave. Okay, if we talk about troughs, if we talk about the troughs, okay, this is the trough. Okay, two consecutive troughs. This is the wavelength here. Okay, wait. This one and this one. This is going to be another wavelength. Okay, that is the distance between two waves, you can say. Okay, this is first one and this is second one. Okay, right? Okay, this is the distance between two consecutive crests and troughs. That is represented by lambda. Right? Okay, then frequency. What is this? Frequency is the number of oscillations. Right? So it is number of waves passing through a point in the space in a per unit time. Okay, in 1 unit time, the number of waves that you have, that is the frequency. Okay, and what is speed? Speed is always 10 to 10 raised to power 8. Amplitude, that is the maximum. This part, this is the amplitude, this is the maximum amplitude that you have from the axis to the crest or axis to the trough. Right? Okay, that is the amplitude. What is wave number? That is inversely, that is opposite of wavelength. That is the wave number. Okay, so few things here, few definitions here, that wave number is equals to 1 by lambda and c is equals to mu lambda. These are the two things that you must know before proceeding towards. Right? Next we have electromagnetic spectrum. So there is this spectrum. This is the spectrum. Okay, this is the spectrum. Very important. Cosmic rays. Firstly we have, this is the cosmic rays, then gamma rays. This is the increasing wavelength. Okay, wavelength is inversely proportional to the frequency as well. Is equals to, we have c is equals to mu lambda, right? Okay, so mu is inversely proportional to the lambda, right? Okay, that is inversely proportional. Students always get confused with frequency and this. Wave number is equals to 1 by lambda, but frequency is directly inversely proportional to 1 by lambda. Okay, that is the difference. Okay, this is the frequency, and this is wave number. So this is an increasing order. Firstly cosmic rays, then gamma rays, then X-rays, then UV, then visible, that we saw, that is seen by us, that we can see through our eyes, right? Okay, that is visible, then infrared, then microwaves, then we have maximum wavelength of radio waves. Okay, this is also asked, this pattern is also asked in your questions. Okay, yes. Now this is the Vedantu pattern. This is the Vedantu. Here you see V, this is V, I, B, G, Y, G, Y, O, R. Okay, this is the thing here. Right? Maximum wavelength is of red. That is having minimum frequency here. That is having the minimum frequency. Next is the limitations. Now all the things are not, like we say, okay, electron is always in the wave nature. No, because there are few experiments that is not answerable by only wave nature. Yes, we can say infrared, we can say diffraction, we can say interference. Like there are so many phenomena that explain the wave nature of the particle. But there are also so many experiments that says that the electron is actually not wave nature, it is the particle nature. So for that we have few experiments. That is, first is black body radiation, next is photoelectric effect, right? Photoelectric effect, that is variation of heat capacity of solids as a function of temperature, right? Next is the line spectra of atom with hydrogen. Now these four things, out of which in detail we are going to do black body radiation, photoelectric effect and line spectra. Yes everyone? Yes bacha? Okay, so now let us do the question here. Let us do this question here everyone. A yellow light emitted from the sodium lamp has wavelength of this much. Calculate the frequency. This should not be, this should be mu, right? And wave number, this should be wave number of the yellow light. Okay, they are saying the lambda, they have given the lambda for this. Just apply these two formulas. C is equals to mu lambda. Okay, we know the value of lambda, we know the value of, or you can say mu is equals to C by lambda, right? We know the value of C, that is 3.3 into 10 raised to power 8. We know the value of lambda, that is 580 into 10 raised to power minus 9 meters, right? Okay, yes. Next is, this is the frequency, wave number is equals to 1 by lambda, right? Apply these two formulas and you will get the answer here, right? Okay, just apply these two formulas and you will get the answer here. 1 nanometer is equals to 10 raised to power minus 9 meter and 1 Armstrong is equals to 10 raised to power minus 10 meters. Right? Now, let us discuss the black body radiation. To discuss the black body radiation, let us see this. What is black body radiation? Okay, let us see what is black body radiation. Now, if you know iron, right? If you heat the iron, what you will observe? You will observe the continuous change in the color, right? Firstly, it will get, okay, first it become red, then yellow, then finally white, then beta blue. Okay, if we heat any solid or especially iron, there are so many color variations. Now we know that for every color there is proper wavelength associated with it. That means it is changing the wavelength. If it is changing the colors, that means it is changing the wavelength. If it is changing the wavelength, how it is possible to show wave nature? Because in a wave, if it is behaving like a wave, it should have a proper wavelength. It should have just constant wavelength. But it does not have a constant wavelength. It is changing the wavelength. Okay, it is continuously changing the wavelength. That means it does not have wave nature. It has particle nature. Okay, the ideal body which emits and absorbs all frequency, and emit frequencies of different, emit radiations of different frequencies, right? Emitted by such body is called black body radiation. Okay, that thing is called black body radiation. Yes, bacha. Okay, what it did? If the color is changing, the wavelength is changing. If the wavelength is changing, that means it is not a wave. It is a particle because we have no constant wavelength here. Right? Okay. Any problem here? This is called Wien's displacement law. Okay. That it is continuously changing the colors. So this is all this is written here according to electromagnetic theory. Energy is emitted and absorbed continuously. Hence, energy of electromagnetic radiation is proportional to intensity, independent of frequency. According to wave theory, radiations emitted by body should have same color. That means same wavelength. But now, when we heat it, the frequency of radiation emitted increases. That means if color is changing, the frequency is changing, the wavelength is changing. That is the reason we say it does not follow wave nature. It follows. Should we convert? That depends in what they have asked you. Okay, in what because in this case the speed was in meters and the wavelength was in nanometers. Either convert the speed also in nanometers and answer this question in nanometers. Right? The SI units should be same. Right? Okay, the units should be same. Next, bacha, very important graph from your NCERT. See what you can see through this graph. Okay, what we can observe from this graph. That as we increase the temperature, we are increasing the temperature. Okay, what is happening? On increasing the temperature, everybody here, on increasing the temperature, what we can see? As we increase the temperature, this is the lambda max, okay? This is the lambda max, 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 lambda max, lambda max. The lambda max is decreasing. That means maximum, we can see lambda max is nothing but it is the wavelength associated with the maximum intensity, right? Wavelength associated with maximum intensity is called lambda max. Okay, lambda max is, I am writing it here, lambda max is wavelength associated with maximum intensity. As this is the intensity, so this point is having maximum intensity. This is having maximum, this is having maximum, this is having maximum, this is having maximum. Right? In case of these graphs. Okay? Yes. So what we can see, on increasing the temperature, lambda max is decreasing. Lambda max is decreasing. And if lambda max is decreasing, this means that, okay, lambda max is decreasing. Also what we can say, the intensity is always this lambda, the intensity, the maximum intensity is this. Increasing the temperature, the intensity is increasing, right? The intensity is increases. These are the conclusions that you draw from this graph. Yes, bacha? Okay? Yes. Now, explanation we can know that how it was explained. It was explained that the particles, the electrons are actually not wave, it shows particle natures. That is why the frequency is getting changed here. When some solid substance is heated, the atoms of substance are set into oscillation, emit radiations. Okay, they get excited, they emit radiation. They get excited, they emit radiation. Everything, when it get excited, it emits radiation. When it emits radiation, it gives you a frequency and energy, right? Okay, so as the heating is continued, more and more electrons, more energy is absorbed by the atoms. They emit radiation of higher and higher frequency, and hence a red light has minimum frequency, yellow has maximum frequency. Therefore the body on heating becomes first red, then it becomes yellow, and so on. Understood this? Minimum to maximum frequency. What it does? It goes from minimum frequency to maximum frequency. Or you can say maximum wavelength to minimum wavelength. Yes? Okay? This is how it changes colors. How it changes colors from minimum frequency to maximum frequency. That is from red to violet. Okay? From red to violet. Okay? Yes, bacha? Understood this? Yes. Okay. Next, bacha, we have Planck's quantum theory. Now, seeing all these things that, okay, there are so many things. Now we have black body radiation. We will also study photoelectric effect also. After seeing this, what he said, that actually electron is in packets. The packets are these. Okay, it has packets like these. It has these kind of packets. Okay, electron has particle nature. Like you have Lay's packets, Kurkure packets, same way. That is not, we can say 10 kg, we need 10 kg Lays, we need 20 kg Lays, no, we need 50 grams Lays, no, we say we need 1 packet Lays, we need 2 packet Lays, 3 packet Lays. Same way, electrons are in form of packets here. Okay, the packets are, this is the smallest packet. Okay, and the energy will be NH mu, where n is going to be either 0, 1, 2 and so on. It is going to be 0, 1, 2, 3, 4. Not in fraction. Okay, it is not going to be in the fraction. That is the Planck's quantum theory. The radiant energy is emitted or absorbed not continuously. Okay, we can say it is continuously giving. Okay, we can say it is continuously giving the electrons. We say this is in packets. It is in packets. Okay, it is in particle. This is the wave nature. This is the particle nature. This is the particle nature. Yes, each packet of energy is called quantum. That h mu is 1 quanta, right? In case of light, quanta is called photon. If you talk about the light particles, the particles of light, each packet is called as photon. Okay, that is called as photon. That is the name given to it. Now, these are the packets. Okay, here we say what is h mu? What is this mu? Mu is equals to c by lambda. Okay, that is from the wave particle. That is c by lambda, right? Okay, this is the Planck constant. That is h. That is 6.6 into 10 raised to power minus 34 joules second. Right? This is very important. Planck's constant. We know this. Like we apply this throughout physics and chemistry. Right? Okay. So this E is equals to NH mu, where N is going to be an integer 0, 1, 2, 3, 4 and so on. Right? Okay, bacha? Understood this? Next, let us see this question. The energies E1 and E2 of the two radiations are 25 and 50 respectively. The relation between their wavelength is going to be E is equals to hc by lambda. Okay, we know what is the variable here. Hc is constant. Planck's constant is constant, and C, energy of light, is also constant, right? So this is going to be lambda. We can say E1 by E2 equals to lambda 2 by lambda 1. Okay, just put the values here. Right? Okay, just put the value of E1 and E2 here, you will get the answer. Okay, just put the value of E1 and E2 here, you will get the answer. E1 is nothing but it is 25, it is 50, this is going to be 1 by 2. Okay, this is going to be 1 by 2, lambda 2 by lambda 1. So it is lambda 1, it's going to be lambda 1 is equals to 2 lambda 2. Okay, lambda 1 is equals to 2 lambda 2. That is B is going to be the correct answer here. Yes, very good, very good. B is going to be the correct answer here. Right? Let us see, for a given energy, we have the given energy. Corresponding wavelength is, what is the corresponding? Very easy, E is equals to hc by lambda. Okay, Planck's constant, then C value. Then you have the value of energy here. Just put the value of, okay, then calculate. Okay, lambda is equals to hc by E. Okay, hc by E. hc by E. Just put the values here and you will get the answer. Okay, just put the values here, you will get the answer. Always see the answer is in nanometers. The answer is in nanometers. Okay, this is in joules. The answer is in nanometers. So you have to write the answer in nanometers, not in meters, because these are in SI units. Also, you will put the Planck's constant in SI units. Then you also put the C, light in SI units. You will get the lambda in meters. Okay, then convert it into nanometers. How you convert it into nanometers? Yes, bacha, how do you convert meters into nanometers? 1 meter is equals to 10 raised to power minus 9 nanometer. Okay, right? Okay. Sorry, just multiply this with 10 raised to power 9. Okay. Yes. Now what you will get here? The answer is 656 nanometers. Okay, the answer is going to be 656 nanometers. Okay, bacha? Yes, perfect, perfect. Next is photoelectric effect. Next is photoelectric effect. That was simple calculation based question. Okay, now let us discuss about photoelectric effect. See this, very simple, very interesting. One of my favorite, very simple. Now see, you have one metal plate. You have this metal plate. In metals, you know that metals is actually, the structure here is, you have kernels, or you can say kernels, right? These are the metal kernels, and electrons. Metal kernels are embedded in the metal, right? And electrons are moving here, They are vibrating here. Electrons are vibrating here in the metal surface, right? Okay, this is the structure of metal, and this is the electrons in the metal. Now, this is the voltage. What you will do, you will apply the voltage, right? And from that, what's your task? To emit out the electron from the metal. To emit the electron from the metal, what you need to do? You need to give it some energy. So that energy that you are going to give it, that energy is going to be h mu. Okay? You are going to give this energy, E is equals to h mu. You are going to give this energy to the metal, right? The energy is going to strike here. Now, if you want to take out your friend from their home and eat something outside, what do you need to do? Firstly, you need to, convince their parents, right? So, first task is to convince the metal to give the electron, right? So, that convincing, the energy that you will give for convincing their parents will be h mu naught. That is the energy required to take out the electron from the metal. Just to take out the electron from the metal, that is h mu. This is called the work function. Okay, this is called the work function. This is called the work function, right? And this is this mu naught is the threshold frequency. It is the threshold frequency, right? The frequency, the minimum frequency required here. And you took out your friend from their home. Now you have to, take them to that stall or anything that you want to eat, right? So what you will do? You will also use the petrol and all that. That petrol and that energy that you are going to use, that is plus half mv square, because you are going to, move here and there. That will take your energy. That is the energy of motion, right? Kinetic energy is energy of motion. You want to take out your friend. Now what you will do? You will roam around. That is energy of motion. So kinetic energy will be needed here, right? That is half mv square. This is the energy that you are giving. You are taking out the electron and you are taking out the electron for the roaming around the city. Now, if mu is more than mu naught, If mu is more than mu naught, right, then there will be kinetic energy. If mu is less than mu naught, if mu is less than mu naught, you are not able to convince their parents to take them out of their house. So no electron taken out. If mu is equals to mu naught, that means you are able to take out them from their house, but you are just standing outside their house. You are just talking and their parents are saying, okay, you can take them out of their house. Just stand outside the house. You are not allowed to roam around. That means there is no kinetic energy. Electron out of metal. Electron is out of we have taken the electron out of the metal, but it is not roaming around, right? There is no electron that is roaming around. There is no kinetic energy, right? Okay, this is the thing. Next thing, bacha, very important. Next thing is, if you want to stop, if you like, there is someone there is more jealous friend of yours who is saying, okay, they are standing outside, now they want to roam around, I won't let them roam around. So what they need to do, they need to stop you. To stop you, they need to give you stopping potential, right? That is kinetic energy, the energy that is required to move the electron. We need to provide the same amount of energy, that is Q into potential. Or for electron, we can say this Q is nothing but E. Right? And this is called the stopping potential. Stopping potential. And here we can say that the new statement is going to be plus EV. That is the electron potential. Okay? Understood this? Yes, bacha. Understood this? Yes. Okay. Any problem till now? Any problem? Okay. Now, bacha, let us read the points of photoelectric effect. The electrons ejected out only if the radiation striking the surface of the has least minimum frequency, that is the threshold frequency, that is represented by mu naught. Then minimum energy required to eject the electron is work function, that is equals to h mu naught, that is the work function, right? The kinetic energy of the electron ejected depends on the frequency. This is very important line, very important line. The kinetic energy, how much amount will be, also one more thing. One photon will only abstract one electron. That one photon is able to eject only one electron, right? Okay, if there is one photon, the intensity is increased. That means the number of photons are increased, right? But they are going to eject only one photon, is only capable of ejecting one electron here, right? Okay, yes. So kinetic energy of the electron ejected depends on the frequency of the incident radiation as independent of the intensity. What does this mean? That number of photon is not going to define how many electrons are going to ejected out. One photon will, no matter how much is the intensity, one photon means one electron, right? Always. But if the kinetic energy is very high, the frequency, the mu is very high, the mu of incident radiation is very high, that will define what will be the kinetic energy. If the convincing power of your friend is very high, okay, we will go to MACD, we will go to Goa, we will go here and there. If the convincing power is very high, your roaming capacity will be very high. The kinetic energy will be very high, right? Okay. The number of photon electron ejected is proportional to the intensity of the incident radiation. What I say? The number, how much? One photon is equals to one electron. So number of photon ejected will be equals to number of photons, right? Number of electron ejected will be equals to number of photons. That means the intensity. Yes, bacha? Everyone? Yes, photon is loyal for his electron. Only one photon, one electron. No hera-pheri. Right? Yes. The loyalty, be like photon. Yes. Next is Okay, but we have done this, okay? Greater the energy possessed by photon, greater will be the transfer. We have done everything, okay? We have done all that, okay? Just read it out. Next is, this is the equation, that is h mu is equals to w, that is the work function is equals to half mv square, or we can say h mu is equals to h mu naught plus half mv square, right? Done this, right? We have also done one more thing, that is this half mv square will be equals to the stopping potential, that is E into stopping potential. V is the stopping potential here. We can write it S here in this form, right? Okay? Yes. Next is the question for you, everybody. But kicks it out of the metal. Yes. Because dil wale dulhaniya le jayenge. The groom is going to take the bride now from their house. So that is why photon came, right, with Bharat and all that. So to take away his bride, that is our electron from the metal. Metal is the house of the bride. Yes, beta? Yes, beta? Okay. Now, the frequency of the wave of light is this, okay? This is the frequency of wave of light, okay? This is the mu. The wave number associated with the light is very simple, okay? With wave number, you can calculate for frequency. You can calculate the lambda here, okay? With frequency, C is equals to mu lambda. You can calculate the lambda, and this is actually, you can also put this 1 by wave number. So calculate the wave number mu by C. Okay, this is going to be the wave number. Mu is the frequency here, C is the light, right? Just put the value of frequency here, that is 12 into 101. This should be 10 raised to power 14. Okay, this should be 10 raised to power 14, right? Divided by 3 into 10 raised to power 8. Right? Okay. Yes, now everyone just put the values here, just put the values here and you will get your answer. Okay, and you will get your answer. Yes, okay everyone, you will get your answer. This is the lambda, opposite to lambda we have wave number, right? Wave number is opposite to lambda, just directly apply this formula. That is wave number is equals to mu by C, right? Okay, yes, very good, very good. That is 4 into 10 raised to power 4 centimeter inverse. Next is electromagnetic radiation of wave number this much. Wavelength is this. Is just sufficient to ionize the sodium atom. Okay. Calculate the ionization energy of the sodium in this. Okay, saying electromagnetic radiation of wavelength this is just sufficient to ionize the sodium atom. It is sufficient just to take out the sodium atom, right? That is equals to work function. Calculate the ionization energy. This is talking about the work function here, okay? That is h mu naught. That is equals to h mu, because mu is equals to mu naught. He's saying just sufficient because it is only able to convince the parents, right? It is not able to convince the parents to, take away the bride and roam around. No. It is just able to convince the parents. That's it. Okay. So it will be mu is equals to mu naught. This is going to be the answer. So put the value of this is going to be hc by lambda, right? And this is going to be h Planck's constant into c. That is the speed of light, and lambda. Here you have this the lambda, right? This is the lambda. Right? Okay, bacha, understood this? Yes, very easy, very simple. What does this statement means? That they are talking about the when mu is equals to mu naught. When the incident light frequency is equals to the threshold frequency. Right? Okay? Yes, everyone here. Yes, everyone here. Given wavelength is this much, E is equals to this is the wavelength. Now, wait. They are talking about this in kilojoule per mole. Okay, they are talking about per mole here. For per mole, you are going to divide it by the number of atoms. Okay, this is going to be per mole. We are talking about 1 mole here. 1 mole has how many particles? It has 6.6 into 6.02 into 10 raised to power 23 particles. That you are going to multiply this by Avogadro's number. Okay, you need to multiply this with the Avogadro's number, because they are talking about, this is per atom. They are talking about kilojoule per mole. Firstly, convert this into joules. Convert the joules into kilojoules. Okay, multiply by 1000 and that will be converted into kilojoules. Right? Okay. No, multiply it by 10 raised to power 3 and that will be kilojoules, right? And then multiply it by Avogadro's number. For example, that is energy. Work function multiplied by Avogadro's number will be the answer here, right? Or I can say h mu multiplied by Avogadro's number is going to be the energy here. Okay? Yes, everyone? Yes. Multiply this by Avogadro's number. That's it. Yes, bacha. Next, let us see. This is the solution. Just all the solution. If the photon of the wavelength this strikes on, they are saying you have a photon which has a wavelength of this much, strikes on the atom. Okay, this is the incident, that is lambda is given to you. One of its inner bond electron is ejected out with velocity this. Inner bond electrons is ejected out with velocity this, that is half mv square we can calculate from here. Energy will be the bond is to with which it is to bond to the nucleus. Calculate the energy with which it is bonded to the nucleus. They are talking about h mu naught, you have to calculate. Okay, we know that we have h mu is equals to h mu naught plus half mv square. M will be the mass of electrons here, that is 9.1 on 10 raised to power minus 31 kilograms. Velocity is given to you, right? And you have h mu, you have lambda here, right? Okay, h mu naught equals to h mu minus half mv square, and that will be hc by lambda minus half mv square. Just put the values here. Just put the values here and you will calculate, you will be able to calculate the work function. Okay, they are just asking you the energy, that is the work function here. Yes, bacha? Yes, bacha? What happened? Who is the? Okay, bacha? Understood this? Yes. Next we have, this is the same thing. Okay, just apply the formula here. H is the Planck's constant, c is the velocity of light, that is 3 into 10 raised to power 8. Lambda you are provided here. This is in picometers. Okay, convert this into meters. Okay, then after that put the value of mass, that is mass of electrons, 9.1 into 10 raised to power minus 31. Then you have velocity, that is given to you in meter per second. Okay, the answer will be in joules. Okay, the answer will be in joules because all the things are in meters. Okay, are in SI units. Next, bacha, we have dual nature of electromagnetic radiations. Now, the dual nature of electromagnetic radiations, we know one thing. Just a minute. Okay. So, the dual nature of electromagnetic radiations, we know that we have seen 2-3 things here. We have seen photoelectric effect. We have seen black body radiations. That shows that there is particle nature. Right? We know the wave nature is shown by interference, diffraction. There is all that you have studied in physics. They all shows that it shows wave nature. Right? Okay. So in that case, ma'am, mainly direct substitution. Yes, you just need to substitute the values here. Right? Okay. You will be, you can see the answer. Right? You just need to substitute the values given to you. That's it. Okay. Substitute the values given to you in this formula, you will get the energy, that is the work function. Why they calculate the energy with which it is to bond to the nucleus. That means they are asking about the energy that is used in emitting the electron, in ejecting the electrons. Okay, yes. Now next we have the dual nature, right? Dual nature means they show there is no confusion. Electron can both behave as a particle as well as a wave. Both it can behave as a particle and as a wave. Right? For that we have deprogrammed wavelength and all that. Okay? We have, firstly let us talk about the spectrum. Spectrum is nothing. Whenever the electron is getting excited, it is moving from one orbit to the other orbit. We will study that in Bohr's model. Okay, it is getting excited, moving from one orbit to another orbit. It is going to come back to its original position. Okay, it is going to absorb energy, get excited, then lose energy and come back to the original position. That way we can say it is emitting the energy. It is giving out the energy. That means it is going to form the spectrum here. Okay, when the ray of white light is passed through prism, wave with shorter wavelength bends more than one. Okay, now what they are saying. Okay, now let us talk about the spectrum here. Okay, this is the white light. What it is going to do? It is going to get splitted into behaviour. It is going to get splitted into behaviour. Okay, it is going to get splitted into behaviour. And how it is getting splitted? They are saying the wave with the shorter wavelength. That means violet bends more than one with the longer wavelength. Here we will have, this is bending, this is behaviour. Okay, this is behaviour. Right? Red with a larger wavelength is going to have the least bending in through the prism. Right? This is the spectrum here. Now, bacha, we have two kinds of spectrum. One is absorption, second is emission spectrum. Now, let us see what is absorption spectrum. Then we will see what is emission spectrum. Okay? Very important, very easy. Right? So, any theoretical question, conceptual question can be asked from this. Now, very simple thing. Now, you see, this is a white light. This is a source of white light. We know white light has behaviour. Right? It has colors, all the colors. Right? Now, white light has behaviour. Now, if I put some absorbing mixture, if I put some absorbing material in between the white light and the prism, okay, this is the prism, this is the absorbing sample. That sample is going to absorb any wavelength here, okay, it is going to absorb that wavelength. And what you will observe in the spectrum, that in few spaces, you will have these dark spots. You will have these dark spots. That means some wavelength is absorbed by some wavelength got absorbed by the absorbing sample here. Right? Okay, that is the first thing. Right? Next, bacha, next we have emission spectrum. Emission spectrum is to emit. Now we are not using any white light here. What we are using? We are heating the sample. We are using a gas either on a high voltage or we are heating it, right? The electrons are getting excited. Whenever electrons are getting excited, they will get de-excited, right? Electrons get excited, they get de-excited. When they get de-excited, they will release the energy, right? They will give out the energy. Energy will have some frequency. E is equals to hc by lambda, right? That means every energy is going to have some frequency. Every energy is going to have some wavelength. So it will have some wavelength. So now this is if suppose we are using hydrogen gas here. We are applying the voltage. The electrons are going to get excited, de-excite, release the energy with some specific frequency, some specific wavelength. So now that wavelength is going to pass through this and then it is going through the white prism. Then it is going to the prism. We are not using any white light in the emission spectrum. We are using a gas which is heating or by giving voltage, anything. We are exciting the electron, de-exciting it, energy is produced, right? And that energy is able to give us this spectrum, right? We see there are some bands in the spectrum. We see instead of dark thing, we see some wavelengths there. That means it is producing some wavelength associated with a particular color, right? That is the emission spectra. Okay, this is the emission spectra. Yes, everyone, any doubt in this? Emission spectra, absorption spectra? Yes, bacha? Okay, I'll take rest after this. Okay, I'll take rest after this. Let me complete this before starting the Bohr's model. I'll take rest. Okay? Yes? Yes, bacha? Okay. Now, emission spectra. This is the emission spectra. This is the absorption spectra. Yes, bacha? Any doubts on this? This is the Bohr spectra. Okay? So, let us start the Bohr spectra after the break. Okay? We'll start the Bohr spectra after the break. Okay, bacha? Yes. Yes, I think I need some rest now because my arm is little paining now. So I'll need some rest now. Okay. After that, we are going to cover Bohr model and quantum model. Right? Okay. 1.5 more hour will take it to cover the lecture. Yes. Okay, everyone. So I'm giving you a break here. Wait. Let me use the tools. I'm going to give you a break. Okay. I'm going to start the break here. I'll give you break for 10 minutes. Okay. For 10 to 15 minutes. Okay. This is 7:57. I'll see you at 8:10. Yes. Okay, everyone. Yes. 8:10 or 8:15. Okay. You must be here at 8:10. Maybe I'll try to be here at 8:10 or 8:15. Yes. Okay. Okay. Then I'll see you in 10 minutes. Yeah. Okay, so guys, I am back, everyone, in the chat box. Yes, am I audible? Am I audible, everyone? Shall we start with Bohr's model and quantum model? These two models, very important. Short questions are going to come from this. Okay, I am going to simplify these two models for you. In Bohr's model, we have few formulas from where questions are definitely asked. Then from quantum numbers, N, L, M, spin and electronic configuration, all these questions are asked. Okay, this is the most important part of today's lecture. From now, the most important things are going to start. Yes, everyone? Ready? Ready? Ma'am is here, but the students are, I think, eating or something. Yes? Okay, chal. Let us start the Bohr's model here. So what Bohr suggested, he suggested that after Rutherford, okay, he suggested that this is the nucleus. He said this is the nucleus. He said in nucleus you have neutrons and protons. And electrons are revolving around the orbits. This is the nucleus. And these are the orbits. He said orbits. That is the shells, okay? These are the shells. He's saying these are revolving around the orbits. And he also said one thing, okay? He didn't say shells, he just said orbits, okay? Yes. And he said every orbit that is represented by N has specific energy, right? Either, for example, this has energy E1, this has energy E2, this is N1, this is N2. He said for every orbital, orbital is for quantum, right? Just skip of tongue, right? For every orbit, we have specific energy. Either the electron can have energy E1 or E2 or E3 or E4 or E5 or so on. An electron cannot have energy except for the energy of orbital, right? Why I am saying orbital and orbital again and again, energy of orbit, okay? Even if I say orbital here, that means orbit only, okay? That is just, I don't know why I am saying orbital here. Yes, E1, E2, right? So this is what he said. Now, he also gave for different orbitals, we have nth amount of orbits, he gave different formulas. He gave formula for velocity, he gave formula for time period, he gave formula for radius, he gave formula for energies. So he gave formula, okay, this total energy. All these formulas are most important for you in this. Very important for you. Okay, firstly let us go through the postulates. That is, electrons revolve around the nucleus in certain orbits of fixed energies. They are stationary or the orbit of the electron. He also said one thing, that if an electron wants to change the orbit, it will have to, for example, an electron on this E1 wants to change the position from E1 to E2. So it wants to jump from E1 to E2. It will have to absorb the energy. They absorb the energy gap. The energy gap, that means E2 minus E1. It has to absorb it, right? Then only it can jump to E2, right? Okay. Next thing that he suggested, that if it wants to, from E2 to E1, it wants to come, it will release the energy. That energy release will be E2 minus E1. This energy will be released. Okay. One more thing he said, that whenever you see question that first excited state, this means they are talking about N plus first excited state. This means this is the first excited state. This means 1 plus 1, that is 2. For second excited state, that means 2 plus 1, that is 3. They are talking about third orbit. Okay. If we talk about nth excited state, orbit is going to be, the number orbit is going to be n plus 1. Right? If this is the excited state. This means what they are saying, orbit is equals to excited state plus 1. Okay? Yes? First excited state means this first excited state plus 1. That is second they are talking about. Okay? Yes. Now let us go through the postulates here. Next is, let me also give you a very brief introduction to this because I don't want to waste your time here. Right? I don't want to waste your time here. You know, all the postulates and everything. Let us jump to the formulas that are going to come in your n square by z Armstrong, right? Okay, I'm going to write all the formulas here, right? I'm going to write all the formulas here. This is the formula of radius. This z is the atomic number, that means number of protons. Okay, always remember Bohr model is only applied to one electron species. This is only for one electron species. One electron species like hydrogen, helium positive, lithium 2 positive, okay, which has only 1 electrons. This is only applied to one electron species. This is the Rn. What is the value of Vn? What is the velocity here? Everyone, what is the velocity here? That is 2.18 into, we're talking in centimeter per second. This is 10 raised to power 8 centimeter per second. Right? You can go through the units, okay? Units are very important. You can convert the units according to the question. Okay? Yes? This is Z by N meter per second. Centimeter per second. Right? This is a radius, this is a velocity. Next we have another is the time period, okay? Time period, or you can completely remember this, okay? This is 1.63 into, because I have not crammed the formulas, right? Because my task is to make the concept easy for you, right? Yes, z square. This is in, I think, seconds. Yes, this is in seconds. Yeah. Then see this. What you can also write it. If you don't want to learn the formula of time period, these two things are asked directly to you. Radius of nth orbital and velocity of nth orbit. Right? These are directly asked to you. Why I'm saying orbital again and again. Then the time period. Right? That is this one. Or you can just remember that time period is directly proportional to n cube by z square and frequency is directly proportional to z square by n cube. Right? This is the first thing. Next is the energy. Next is the total energy. Right? Next is the total energy. Yes, bacha? So now remember this thing, that total energy is equals to kinetic energy. Total energy is half of the kinetic energy, half of the potential energy, and if you remember these two things, you can equate this and you will write kinetic energy is equals to minus half of potential energy, right? These three formulas. Next we have the formula of total energy. Then you just need to remember the formula of total energy. That is minus 13.6 z square by n square electron volt. This is an electron volt, okay? This is electron volt per atom. This is an electron volt per atom, right? Okay? Also remember in joules. In joules you will write total energy is equals to weight. In joules also you need to remember this. 1321 z square by n square kilojoule per mole. Okay. Now you have to cram all these formulas, right? All these formulas, one question is going to come from these formulas. Now I'll tell you after write it down and paste this paper in front of your bed or something where you go through these formulas daily, right? Now, after going through the formulas, if you learn these formulas, things will be very easy for you. Now, for example, how they are going to ask you the question in the exam, okay? How they are going to ask you the question, see this. For example, they have asked you that you have an atom which has radius R1, atom 2, this is atom 1, which has radius r2. This is nth orbital, this is n2 orbital. So, to compare these things, same applies to velocity, same applies to everything. So, you know that R is directly proportional to n square by z. R is directly proportional to n square by z. Now, if they talk about the same atom, Z will also be extracted out. If we talk about the different atom, this is atom 1, this is atom 2. That means this is Z1 and this is Z2. Right? We are talking about different atoms here. See this very carefully. If they are talking about different atoms, what you will do here? This will be R1 by R2 equals to N1 square by Z1 into N2 square by Z2. Okay, they can ask you any of the variable thing here. Okay, they will give you, for example, the atom 1 is helium and atom 2 is lithium. Both are, a single electron, they have cations, right? Then they will tell, okay, for helium you have 2 and for lithium you have 3, right? Z is 3. Right, then they will tell you that R1 for helium is this much, R2 is this much, and in helium we are talking about the 4th orbit. What is the orbit of second atom? That is lithium. So how you will write it? Just this is the formula that you will use. Okay. Now if they have given you the same, atom, if they say the atom is same, in that case what you will write here? You will say R1 by R2, very important formula, N1 by N2 whole square. Very important formula. Okay, similar way we are going to, yes bacha, I am completing all the concepts I am completing here. Okay, so here this is the first thing that they can ask you from radius, and similarly they can ask you from the velocity also. Velocity is directly proportional to z by n. If they are talking about the same atom, you will say v1 by v2 equals to n2 by n1. This is the answer for velocity. Okay, this will be the answer for velocity. Similarly for time period, similarly for frequency, and same for total energy, potential energy, kinetic energy, anything they can ask you. You just need to cram all this. Unfortunately, you have to. Okay, some formulas you need to cram, right? If you want to excel, right? Okay. Yes, bacha. Next, let us see the energy difference. If you want to calculate the energy difference, some atoms want to. What is the difference of the energy from this to this? This is E2, this is E1. Okay, this is E2, this is E1. This will be delta E. That will be E2 minus E1. That is H mu. That is Hc by lambda. Okay, E2 minus E1. Now, next is very important formula, that is angular momentum. This is according to, this is according to the Bohr model. Okay, angular momentum of the stationary orbit is going to be integral multiple of h by 2 pi. Okay, very important formula, that mvr is equals to h by 2 pi. Integral multiple, that is nh by 2 pi. Yes, this is a quantization of angular momentum. Why quantize? Because this is going to be the integer here. Okay, next is the calculation of radius and all that. We have already done these formulas. Okay, we have already done these formulas. We have also done this formula as well, right? Just need to remember this formula. I have already compiled all the formulas for you. This is in picometer. They have given this in picometer, right? I have written in Armstrong. Okay, units you can convert. Next, bacha, this is the velocity. This is the velocity. Right, that is given in meter per second, right? That is given in meter per second. Everyone here, this velocity is in meter per second. I have written that in centimeter per second, right? Next is the formula of kinetic energy, potential energy, the relation between kinetic energy, potential energy. Yes, we have done all this, bacha. All this we have completed. We have completed this also. Okay, I have compiled everything for you. Everything I have written for you. Right? Okay, these are the two most important, very important. Wait, this is z squared, this is wait, Just a minute. Add this formula as well, okay? Add this formula as well into this. Because this is your formula sheet, so I want you to add this formula as well. That is total energy equals to minus 2.18 into 10 raised to power minus 18 z square by n square joule per atom. Okay, they can ask you energy is any of this. In electron volt per atom, in joule per atom, kilojoule per mole. Anything they can ask you. Okay? Right? This is per atom, this is kilojoule. Just convert joule into kilojoule and then multiply this with Avogadro's number, you will get this. Okay? Either you can skip this one, you can also skip this one if you don't want to calculate so many, if you don't want to recall so many formulas, but these two formulas are important for you. Right? These two formulas are important for you. This is the conclusion of Bohr model. This is the conclusion of Bohr model. Right? If you do this, you will be able to solve any question related to Bohr model. Right? Okay? Now let us do the questions. Okay? These are the energies. These are the energies, but after putting the value of, for hydrogen atom, they are calculated for hydrogen atom, Z is equals to 1, and putting the value of orbits here. That is n is equals to 1, 2, 3, 4. These are the values here. Now what you are going to see that energies are increasing here. Right? Energies are, the radius is this for first stationary called this orbital. The energy of electron with stationary states, principal quantum number n is infinity. What they are saying, he is saying that energy from the negative is increasing to the more positive value here. Right? For n is equals to infinity. Infinity means we cannot predict that. Okay? For electron, even this much thing is infinity for that. Okay? For n is equals to infinity, energy is going to be 0. If we talk about nth orbital, that is infinite, at infinite position. For electron, infinity means you have taken out the electron from the atom. That is the infinity for that. Okay? Yes? Now let us do the questions here. The energy of second orbit means n is equals to 2 of the hydrogen atom. That means z is equals to 1. Here n is equals to 2. They are asking you the energy. Okay, they have given the energy. Hence the energy of the fourth orbit, bacha. We know energy is directly proportional to n square by z square. Right? Okay. That means E1 is equals to, for z is equals to 1, that will be directly proportional to n square. So E1 by E2 is equals to n1 square by n2 square. Right? Just apply this formula. This is, for example, n1, this is E1, this is n2, this is n2, calculate E2. Okay? Just apply this formula, you will be able to answer the question. Okay? For these kind of questions, they can be asked for radius, for velocity, for energy, for time period, for frequency, anything. Just need to the relation between that quantity and if it is directly or inversely proportional to n or z. Right? That's it. Yes, bacha? Okay? Just apply this formula, you will get the answer here. Yes, everyone? I think I have put the value wrong here. This will be 1 by n square. This will be n2 by n1 whole square. Okay? This is going to be the answer here. Yes. So, next thing, bacha, that we have, based on the equation, this is the equation, right? They are saying certain conclusions are written. Which of them is not correct? Right? Which of these conclusion is not correct, everyone? Which of these is not correct? Equation can be used to calculate the change in energy when the electron changes orbit. Now they are saying equation can be used to calculate the change in energy. You calculate the delta E in the energy when electron changes orbit. For n is equals to 1, which of the following is not correct, they are saying. For n is equals to 1, the electron has more negative energy than it does for n is equals to 6. No, it has less negative energy. Right? So this is a wrong. Which means, wait, n is equals to 1, it has more negative energy. Yeah, it has more negative energy for n is equals to 1, which means that electron is more loosely bound to the smallest No, this is wrong because it is highly bound, okay, to the smallest allowed orbit. To less is the number of orbit, right? Less is the number of that orbit. More it is bound to the nucleus because more it is closer to the nucleus. So B is going to be the right answer, right? Okay, B is the right answer. That means B is the correct incorrect statement here. Yes, everyone. Okay. Next bacha we have. Everyone try to answer these questions. No. What are you doing? Huh? My arm is paining. I am still, answering the questions for you. Please answer the question. Okay. So the Bohr orbit radius. They are saying the Bohr orbit for the hydrogen atom n is equals to 1 is approximately this much. The radius of first excited orbital state. Okay, again they are asking you, this is for example, take this as N1, take this as R1, okay, take this as N2 and take this as R2. Okay, first excited state, this is n is equals to 2 they are saying, okay, this is R2 that you have to calculate here, right? Okay everyone, just put the formula here, right, just put the formula here. We know that either you can do it this way, either you can do it this way. R1 by R2 is equals to N1 by N2 whole square. Okay, just put the value here, put the value of R1, R2 and everything. N1 is 1, R1 is 0.52, right? And N2 is 2 and calculate the value of R2 here, right? Okay. Very good. Next bacha, everyone, why the energy is so less? I don't know what happened to this chapter. You don't want to, they were saying, ma'am, physical chemistry, ma'am, physical chemistry. I'm teaching physical chemistry, everyone is like roaming here and there. Now, the radius of hydrogen atom of the ground state, the radius of Li to positive, that means Z is equals to 3 here. Okay, Z is 3 here. They're talking about different radius here, right? They're talking about different atoms here, right? For different atoms, what used to be the formula? R is directly proportional to N square by Z, right? Okay? Yes, now? R is directly proportional to, whenever it comes to learning or cramming something, I am very weak. When it comes to cramming something, yes, N square by Z it is. Right? It is N square by Z. Oh my God. Oh my God. Yes. Oh my God. Yes. So that means R1 by R2 equals to N1 by N2 whole square, and this is Z2 by Z1. That's it. Okay, you just need to apply this formula. This is Z2 equals to 3, the radius hydrogen atom, that means Z1 is equals to 1. In the ground state, that means N1 is equals to 1. Okay, in the ground state is equals to this. This is the R1. This is the R1 here. And this is for atomic number, this is similar state. Similar state, that means N is equals to, N is same here, okay, N is same here. So just need to calculate Z2 by Z1 here. Okay, just put the values of Z1 here, Z2 here, and then R1 here. Okay, that's it. You will get the value of R2. Okay, you will get the value of R2 from here. Right, everyone? Yes? Yes, or for organic, I don't have to cram anything. But I love the conceptual chemistry, but what I don't like about anything is cramming part. I hate cramming part, right? I hate cramming. I literally hate cramming. So let us do line spectrum of hydrogen here. Okay, let us do the line spectrum, how it defined the line spectrum of hydrogen. Okay, here we are going to talk about 5 lines, that is Lyman, Balmer, Paschen, bracket P fund. Okay, these 5 lines, okay, that we are going to talk about. So what happens in hydrogen? You have 1 electron, 1 proton. Whenever this electron is going to get excited, it is going to get de-excited also, right? And that is how it is going to form so many series here. That means what we are talking, the spectrum obtained is called emission spectrum, or this hydrogen gas at low pressure is taken in discharge tube. This is the light emitted on passing electrical discharge is examined with the spectroscope and all those things. Electron get excited, de-excited, releases the radiations, and that is how we get the spectrum. That is the emission spectra. They can ask you, what is the spectra of hydrogen? That is the emission spectra, right? Okay, next thing, bacha. See, due to excitation or de-excitation of electron from one orbit to another orbit, you will see the line spectra here. So, let us see how you see the line spectra. Okay, so there are so many orbits here. Like there are so many orbits. What you will see, if we are talking about any electron, that is, okay, always electron has this one thing. If it is getting excited from n is equals to 1, it will get back to n is equals to 1. If it is getting excited from n is equals to 2, it will get back to n is equals to 2. Right? So all the electrons that are coming back to n is equals to 1 are Lyman series. Okay, this is Lyman series. All the electrons that are coming back to n is equals to 2 are called Balmer series. All the electrons that are coming back to n is equals to 3, those are called Lyman-Balmer-Paschen series, right? This is Lyman-Balmer, then you have Paschen, then you have bracket, then you have P-fund, okay? Then you have P-fund. And for these, electrons are going n is equals to 1, coming back to, electrons are coming back to n is equals to 1, to n is equals to 2, to n is equals to 3, to n is equals to 4, to n is equals to 5. Okay, they are coming back to n is equals to 5 here. Yes, everyone? Yes? Okay, bacha? Yes, perfect. Now, bacha, see this, that where they lie, okay? Let us see where they lie. Very important that they can ask you, very important. These series are very important, okay? So now, Lyman series, these are UV region, okay? And Balmer series are in visible region. All other are in infrared region. They can ask you that you have a series that lies in visible range. They will not give you the N final, that is NF. They will not give you the N2 value here, right? You'll have to say, okay, they are talking about visible region. That means they are talking about the Balmer series. Okay, Balmer series, we know that N1 is equals to 2 here, right? This is the case. And how it is applied? It is applied to this formula, that is Rydberg equation. It is applied to this formula, that is Rydberg equation. That is 1 by lambda is equals to wave number, right? Equals to, this is the Rydberg, this is RH. This is RH. This is Rydberg constant into Z square. If we're talking about hydrogen atom, that will be 1. According to the atom, it will change. Right? 1 by N1 square minus 1 by N2 square. Right? N1 can be 1, 2, 3, 4 according to the series, and N2 will be provided to you in the question. Okay, this will be given to you in the question. This will be provided to you according to the series or the ranges here. If they talk about infrared, we have 3 things for infrared. So they will not give you infrared. Either UV or visible they will provide you. Right? Okay? Yes, but always remember this wave number is in centimeter per second. This is per centimeter, not per meter. Okay? Also one more thing. If you have to calculate 1 by lambda, you know, for 1 by lambda, this is 1 by lambda equals to Rydberg constant. To calculate lambda, you have to know the value of 1 by RH. Right? Only then calculations will be easy for you. Right? Only then calculations will be much easy for you. Is it? Yes, bacha? So, the value of 1 by RH is equals to 912 Angstrom. You can convert Angstrom to meter, centimeter, everything. Right? Okay? So always remember the value of 1 by RH to make the calculations easy for you. If they ask you wave number, directly put the value of RH here. If they ask you lambda, put the value of 1 by RH, not the value of RH. Yes, everyone? Yes, got it? Okay. Next is the shortest and longest line. Now see, If we talk about the shortest means, see, always remember this one, one more thing, that is energy is directly proportional, inversely proportional to lambda. So if we talk about maximum energy, lambda will be minimum. It means we are talking about minimum lambda, right? If we are talking about and vice versa, if we are talking about minimum energy, that means lambda is equals to this. If they ask you for Lyman series, it has maximum energy. If they tell you it has maximum energy, they have not given you any idea about N1, N2 or anything. We know that for Lyman series, N1 is equals to 1. Okay. We do not know about the N2 value here. Let us see, lambda will be minimum. Okay. Lambda can be maximum. They will not give you maximum. They will give you the minimum here. Okay. For example, for lambda, see, for Lyman series, they give you energy is minimum, or they can give you lambda is maximum, right? If they give you lambda is maximum, in that case what you will write, for Lyman series we know that N1 is equals to 1. What will be the value of N2? Which will have maximum lambda, which means energy is equals to minimum. For energy minimum, the gap should be minimum, and the gap is minimum here. That means it is jumping from n is equals to 2 to n is equals to 1. So here we will write n2 is equals to 2. Right? Okay. If they tell you that we are talking about P fund, right? And the lambda is minimum. That means lambda is maximum. That means energy is minimum. Right? So here what we will write? Here we will write that N1 is equals to 1, 2, 3, 4, 5. Lyman, Balmer, Pasteur, bracket P fund. N1 is equals to 5 here. N2 is equals to, what is the value of N2? That is energy is minimum. Energy will be minimum in just one step. That will be N1 plus 1. Okay. That is 5 plus 1. That is 6. Okay. That is going to be 6. Right. Always in this case, if they give you the lambda is maximum, in that case N2 will be equals to this. I am writing it here. In a nutshell, we can say if they give you lambda is maximum, then N2 will always be equals to N1 plus 1. Okay. Everyone understood this? For if lambda is maximum, N2 will always be equals to N1 plus 1. Yes, everyone? Okay, bacha, we will do thermochemistry. Okay, don't worry about this. Yes? Bacha, yes, I am going to definitely complete the syllabus. Don't worry. Yes, shortest line of any series. Shortest line means, shortest line of any series is the wavelength of EMF which correspond to maximum energy, right? Where the energy is maximum, the lambda is going to be minimum, right? Shortest line is also referred to limiting line of the series. That is also the limiting line of the series. That means infinite to n is equals to 1, right? N2 is always going to be infinite, right? Longest line of any series, if they ask you longest line, that will be, they are talking about lambda max. That means energy is minimum. If energy is minimum, then we say N2 is equals to N1 plus 1. Okay. If they are talking about shortest line, they are saying lambda is minimum. They are saying energy is maximum. Energy is maximum. In this case, we will see N2 is equals to infinite. Okay. Yes, everyone? Okay. Okay. Now let us do the questions related to this. What is the maximum number of emission lines when the excited electron of H atom n is equals to 6 drop to ground state? We have n is equals to 6. That is the value of N2. That is the value of N2 here. Right? And this is the value of N1. right? Maximum number of emission lines. Okay, they're talking about the emission lines. Okay, emission lines. There's a formula for that. Okay, let us talk about the formula. If we are talking about everyone, if we are talking about nth to ground state, nth to ground state, if we are talking about n2 to n1, right, it has different formulas, right? In this case, this will be n minus 1 by 2, right? This will be n minus 1 by 2, right? Okay, and in this case, it is going to be n1 minus n2, n1 minus n2 plus 1 by 2. Okay? Yes, everyone? Everyone here, this is going to be multi-electron. Okay, if we are talking about single atom, we are talking about single atom, in that case, it is going to be, these are the spectral lines, okay? These are the spectral lines. This is the formula of spectral lines. This is going to be, spectral line is going to be n minus 1. These are the formulas here that you need to remember to solve this question. Okay, these are the formula that you need to remember to solve this question. Simple formula, put the formula and you will get the value here. Now they ask you the ground, nth to ground state, apply this formula, you will get the answer here. Right? Apply the n is equals to 6, you will get the answer here. Yes, everyone? Now let us do the next thing. That is limitations of Bohr's model. So now what are the limitations of Bohr model? It basically lies in the spectrum itself. Right? So he could not explain the line spectra of atoms containing more than one electron. He explained the line spectra of one electron. Bohr atom only considered one electron system. Right? Second thing, he was not able to explain Zeeman's and Stark effect. What is Zeeman effect? That is the splitting of spectral lines in magnetic field. What is Stark effect? The splitting of electrical field, splitting of spectral lines in electrical field. That is Stark effect. This is also your PYQ. Okay, this is also your question of PYQ. Okay, important. Next is he was not able to explain de Broglie's concept. De Broglie's concept, he was not able to explain that. Okay, then of dual nature. He could not explain Heiseberg uncertainty principle. We'll do all this. Okay, could not explain the ability of atoms to form molecules by chemical bonding and all that. That was not explained, right? So how these were done, how the electrons are getting, excited and all that, he could not explain that. How there is transfer of electrons, right? For that there comes another thing, that is quantum model. So now we are going to shift to quantum model, right? Before that, let's do some questions here. The electron's energy in hydrogen atom is given by this. Calculate the energy required to remove an electron completely from n is equals to 2 orbit. What is the longest wavelength of the light in centimeter that can be used to cause this transition? Okay, just apply the formula, just apply the Rydberg's constant here, right? And you will get the formula and you will get the answer here. Just take the screenshot of this and this is your homework. Okay, this is your homework. Okay, this is your homework. I'll give you. Okay, next thing is, let me see how many questions we have of this. Just few questions. Now let us see next is, what is the wavelength of light emitted when electrons of hydrogen atom undergoes transition from an energy level n is equals to 4 to an energy level n is equals to 2. Similarly, we are going to apply the Rydberg's equation here and we are going to calculate lambda. Okay, here always remember, we have just put the value of 1 by RH is equals to 912 angstrom. Right? The question will be very simple for you. Right? The question is going to be very simple. What they are talking about, undergo transition from n is equals to 4 to this. Okay, n is equals to 4 to n is equals to 2. This is the transition. Okay, this is the n is n2. This is the value of n1. This is the value of n1. Right? Okay. Yes, everyone. Just put the values here. You will get the answer. Yes. Next is according to the Bohr theory, which of the following transition in the hydrogen atom will give rise to the least energetic proton? Now this is an interesting question. According to the Bohr theory, which of the following transition in the hydrogen atom will give rise to the least energetic? Energy is least, right? We know the formula of energy, right? The transition should be least. The value, the N2 minus N1 should be least, right? Okay, for that, just see the formula. Okay, this is the formula. Now, here we know that delta E is equals to 1 by N1 square minus 1 by N2 square, right? If we say that N2 is more than N1, only then we can say this will be least energetic photon. If N2 is more than N1 and N2 is more than N1, we put the value 6, here it is 6 and here it is 5, right? Okay, this will, the gap will be minimum, right? Here the gap is of 2 orbits, here the gap is of 1, here the gap is of so many. So this is ruled out, this is also ruled out. Out of this, which is like, you can, without applying any formula, you can calculate this, right? Okay, this is n is equals to 6 to 5. 6 is having less energy, right? 5 is having less energy. So energy gap is also going to be less, right? So C is going to be the right answer here. Yes, okay. Kya baat? Very nice. Next is de Broglie equation. You just need to remember this equation, that is lambda is equals to, actually gave one expression to combine both wave nature and particle nature. That is lambda is equals to h by p. That is lambda is equals to h by mv. Okay. This momentum is from the particle nature of electron, and this lambda is from the, that is wavelength is from the wave nature of the particle. So just remember this formula. Just remember this particular formula, okay? Or you can write this is H equals to 2mE. E is the kinetic energy here. You can also write H by under root 2mEV, where V is the stopping potential here. So all these formula can be used, okay? All these formula can be used here. This formula, this formula, this formula, this formula. All the formulas that you have to remember in this, okay? They can ask you question based on any formula here, right? Yes, beta. So this is just conversion of these formula. This is just conversion of these formula, that lambda is equals to 1 by lambda is inversely proportional to mass and all that. Okay. Now calculate the wavelength of the electron moving with velocity. This you have this the velocity. You have to calculate the wavelength. Okay. So that means which formula you are going to apply here. The formula lambda is equals to h by mv. This is what you are going to apply in this question. Lambda is equals to h by mv. Right? What is the mass? They are talking about electrons. So the mass is going to the mass of electron, that is 9.1 into 10 raised to the power minus 31 kilograms. This is the velocity, and you will get the wavelength here. Okay? Put the value of Planck's constant, you will get the answer. Okay? Lambda is equals to h by mv. Okay, just apply this formula, you will get your answer here. Next is in hydrogen atom. Yes, very good. In hydrogen atom, the de Broglie wavelength of an electron in the second orbit. In the second orbit, they are saying, okay, in the hydrogen atom, Z is equals to 1, de Broglie wavelength of an electron in the second orbit. Bohr radius is this. 1 minute. What they are asking you, lambda is equals to this, mv. Okay. You have to calculate the value of velocity here, no? Of electron of second orbit. The de Broglie wavelength of an electron. Lambda is equals to h by mv. Velocity can be calculated from the Bohr model, right? We know the value of z, that is 1. We know the value of n, that is n is given to be 2 here. Okay, just calculate the value of velocity from the Bohr model, right? Then put the value here. Put the value of velocity here, you will get your de Broglie's wavelength, right? Okay. See how it is done. See how it is done. Okay, this is another method to calculate it. You can also apply this formula or apply that thing also. Okay, how they have done it here, Okay, how they have done it here. A naught was given to you. So they calculated the value of the radius for the second orbit. After calculating the value of radius for the second orbit, they applied this formula. That is, angular momentum is integral multiple of h by 2 pi. Right? You can apply any formula from the Bohr orbit. Right? Because if we have given this A naught value here, you can apply this formula as well. Right? So here we know the value of n, right? That is the second orbit, h by 2 pi. These are the constants. V is the velocity, m is the mass of electron. Here you can calculate the value of mv instead. Okay? You can calculate the value of mv from here, right? Okay? And then you will get your answer. This is the radius. This is the radius that you will put here. Okay? The thing that I told you is also applicable for this. And you will also go through this method. Both of the method you can apply here. Okay? Yes? Okay? Yes. You can also apply this formula as well. Okay? You can do that as well. Okay? Yeah. This is going to be easy. The calculations are going to be very easy. In that case, doing the velocity and then putting the value here, the calculations are going to be tough. Okay? The calculations will be tough in that case. Here the calculation, just calculate the value of mv from here. Okay, get the radius here, just calculate the value of mv here, right, and to put the value here and take the h as that only, because h will be, we can cut the h after this. Okay, just put the value of lambda LV, right, and put the values here, you will get the answer. It's a little bit complicated, okay, this is a little bit complicated. I'll just tell you one thing here. Okay, I'm just writing it down here. That is, firstly you are given the value of A naught here. Now, Rn is equals to n square A naught, right? Now, mv will be equals to n h by 2 pi. This is divided by r. This is divided by r. R is n square A naught, right? Okay, and calculate lambda is equals to h by mv. And this mv is going to be nh 2 pi n square A naught. So this lambda is going to be, just writing down the formula instead for you, right? Just cancel this nn and this h is cancelled here. This will be 2 pi n A naught. Right? This is going to be your answer. Just apply this formula. You don't need to do all this. Okay? Okay? Don't put the values anywhere. Okay? Just lambda is equals to 2 pi n A naught. A naught is given to you here. And value of n is also is equals to 2. Okay? N value is equals to 2. Right? Okay, everyone? Yes? The calculation is also easy. See, calculation is easy. 2 pi n A naught. That's it. Okay? Yes? Have I done it right? This is 2 pi. This is 2 pi n h. This is h. 2 pi n square A naught. N cut. H cut. 2 pi n A naught. Yes? Okay? Okay, everyone, just put this formula. You don't need to put the values before, just put the values here. This will be 4 pi A naught. Okay, the answer will be 4 pi A naught. Yes, okay. Now let us do the next question. Next thing is Heiseberg principle. So what is Heisenberg's principle? Heisenberg principle means that you cannot, they are saying for a very small particle, you cannot calculate the velocity and the position on the same time. If something is moving, you cannot calculate just, something is just moving and moving and moving, you can calculate the position. If something is like stationary, you cannot calculate the velocity. And this is what they are saying, that we cannot calculate the velocity or the position, or say momentum or the position, because momentum is equals to mv, right? So if I say velocity or momentum, one is the same thing, right? Okay, you cannot calculate the velocity, like momentum, and the position at the same time, right? Okay, this is what they are saying. So delta x is the uncertainty of principle, that is delta x into delta p is greater than equals to h by 4 pi. This is the formula. Okay, this is the formula, or you can say m delta x delta v is greater than or equals to 4 h by 4 pi. This is also the formula that is used. Okay, this formula is also used. Both the formulas are used here, right? Okay, yes. So all these things are written here. If velocity is if the uncertainty in velocity is very less, there will be more uncertainty in the position and vice versa. Okay, that means the position of the electron is known with high degree of accuracy. Then the velocity of electron will be uncertain, right? We cannot find both of them. If there is velocity, if you can find the velocity, you will not be able to find the position. If you can find the position, you won't be able to find the velocity. Okay? Yes? Now, next thing is significance. Significance is that it is only applied to extremely small particles. I cannot determine this for me. If I am driving the car, I know where I am. Right? I can say, okay, I can't identify where I am. Right? We have GPS to identify that. Right? We can identify our position and we can identify our speed. Right? But the micro particles, this thing is not applied to the micro particles. Right? We cannot identify the speed and velocity at the same time. Sorry, the velocity and the position at the same time. Right? Okay? Whose mass is this according to Heiseberg principle? This is only applied to electron with a very negligible mass. Right? Which is having mass of 10 raised to minus 31 kilograms. That is applied here. Right? If we say this is the weight. Yes. Next is, I think they have just shown the calculative part. You don't need to go through that. Okay. This is just even if I tell you what is this, they have just given you this formulation that if you are saying for me, okay, if the mass is like they are talking about the object uncertainty is applied to object of mass, say that about 10 raised to power 6 kilograms. That is still very small. But what you will observe here, extremely small, insignificant uncertainty you have. Right? If we say here, for an electron, the uncertainty is still better than this. 10 raised to power minus 828. If we are talking about 10 raised to power minus 4. Here we are talking about 10 raised to power minus 6. We talk about my mass. I have around 53 kilograms, right? So you put the 53 kilograms here. This is going to be extremely large value. Extremely large value. That is not possible. Right? So that is why it is also only significant to microparticles. At basis of quantum and mechanical model. This is a probability of having a given this. So now what they are saying? They are saying we cannot find the exact position of electron. This was the start of thinking about the quantum model here. Now we are thinking about the quantum model. Now we are thinking that okay, there is some probability thing defined here. Right? Now we are going to start thinking about the quantum model itself. That is based on the probability of finding the electron. Right? Okay? Yes, bacha? Okay. So now let us see the failure of this. This was also the answer to this. In Bohr's model, electron is regarded as charged particle moving in well-defined circular orbit, which is not true. We cannot find the position and velocity. Bohr model find out the radius and the velocity. But that is not possible. We cannot find the velocity and radius. Not possible. Right? Okay. So wave character of the electron is not considered. We cannot see anything that define the wave character. We are taking in Bohr model that is taken as a particle. Right? So Heisenberg principle is automatically ruled out in Bohr's model. Bohr model of hydrogen not only ignores the dual behavior but also contradicts the Heisenberg uncertainty principle. That is why it was failed. Now we have the start of new thing, that is quantum model. A very, very important, very interesting thing. Right? Okay, before that, let us go through the questions here. The mass of the electron is this. They are saying the mass, that is uncertainty. This is the mass. Electron, we know that. Planck's force is this. The uncertainty involved in the measurement of velocity. That is delta V is given to you. Just apply this formula. Delta, this is M, this is delta V greater than or equals to H by 4 pi. Just apply this formula. You will get the uncertainty in position. Right? Okay. They're talking about the wait, they're talking about the uncertainty involved. The distance is this, okay? They have given you the uncertainty in the position, right? Uncertainty in position is given to you. You need to calculate the uncertainty in the velocity. Just apply this formula, put the values, you will get the answer. Okay, just apply. You have the mass, you have the position here, that is 0.1. You have the value of 4 h by 4 pi, right? These are constants. Just put the value, you will get the answer, right? That is uncertainty in the velocity, right? Okay, what happened? Yes. Surely we will remember that. Okay. Now, bacha, let us talk about the quantum model. Okay. Are you all ready for the quantum model? Very simpler way I am going to teach you quantum models. Okay. Then you are going to love quantum chemistry or physics after this. Okay. Let us see the quantum here. Okay. What is quantum? This is basically, I'll firstly just imagine, this is all about imagination, okay? We are just considering electron, that electron is, we cannot calculate the position, okay? We just need to, we have that probability that electron can be here, electron can be there, electron can be there, okay? You know about Schrodinger's cat, right? This was actually the model of Heisenberg principle, Heisenberg and Schrodinger, both, okay? The first name here is Schrodinger's. Okay, Schrodinger's cat. What is Schrodinger's cat? What is Schrodinger's cat is that, for example, if you lock a cat in the box, what is the probability that will be alive or it will be dead? The probability is 50-50. We can only know if the cat is alive or dead after opening the lock and seeing that. This is what they are saying. We cannot say if the electron is present here or there because we are not able to see that, right? So to explain the quantum thing, quantum mechanical model for the general public, he gave this one interpretation of that. That if you cannot see something, you are going to tell the probability of that, right? Similar way, we are not able to see the electron, we can only identify the probability. It was not just like, okay, we are not able to see this, we will tell the probability. It was a proper researched thing, okay? For that, we have one equation. This is the Schrodinger's wave equation. Very important, you just need to remember this equation. Just this equation, nothing more. Okay, this is x-axis, y-axis, z-axis, right? Plus 8 pi square by m h square, E minus V. E is the energy, V is the potential. Right? Okay? Yes. Now let us see one more thing here. That this psi is the wave function. Right? This psi is the wave function. And wave function does not have the significance of its own. But psi square defines the probability. Okay? Psi square defines the probability of finding the electron that we are looking for. Now, let us talk something about this wave function because this wave function is going to tell us so many things, okay? This wave function is going to tell us so many things here. Let us talk about wave function here. This is the wave function. See this very carefully. Listen to this very carefully. Okay? If you find any problem anywhere, just ask me. So there are two values. Okay? Every equation has a solution, right? This equation also has so many solutions. That is the value of psi, right? This is psi. Okay, this is psi. Okay, this is the value of psi. Now, to calculate the value of psi, there are basically two values here. One is the real value. Second is the imaginary value. Second is the imaginary value. In quantum, we are not going to talk about the imaginary values here. Let us focus on the real values, okay? In real values, you get two things here, okay? In real values, you have two things here. One is eigenfunction. One is eigenfunction. And next is eigenvalue. Next is eigenvalue. Now you will ask, ma'am, what is eigenfunction? What is eigenvalue? right? You will ask, ma'am, what is eigenfunction, what is eigenvalue? See this, okay? See this, let us understand what is eigenfunction and what is eigenvalue. See, if we talk about eigenfunction, just remember this thing, that is, this is A psi. Okay? This A is the operator here. All the students who are not from maths background, I guess you guys are obviously, there are just few students who take maths along with medical, right? So see this. Okay, I'm not going to go that much detail into this. Just an overview of this because this is not difficult. Very easy to understand. This is the operator. This is the function. This is the value, the value in digits, 1, 2, 3, 4 value, right? This is the function. How, ma'am? We are not able to understand this. See this, okay? Very easy. See this. If I take psi is the function, okay? Function, we represent it like this. In maths, we represent function as this, f for function, right? X means x is the variable here, okay? So I represent it by, if I talk about two functions here, I am talking about this x4, and next here I am talking about psi is equals to function, that is e raised to power 4x. E raised to power 4x. Okay, these are the two things that I have. So for this, if I put the operator, if I say the operator here is, operator is addition, multiplication, differentiation, integration. Oh my god, all these are operators. Okay, all these are operators. So I say differentiation is the operator here, right? If I apply this here, what will happen? This is d dx x4. So you know differentiation, 4 will be this side, right? X cube, which is not equals to, we cannot see the function again repeated here. Okay, we cannot see x4 here. This is x cube. But in case of exponential, what you will see, this is d by dx. This is e raised to power 4x. And now if you apply this formula, this is e raised to power 4x. Differentiation of 4x is 4. That means here I can say this is the operator, this is the function, this is the value, and this is the function again. That means here the function is repeated. Okay. So that means the function, this is repeated here. So here we will say, no one is going to ask you these questions, okay? But you must know what is eigenvalue, what is eigenfunction. Now this is not eigenfunction. That's it. This is eigenfunction. This is eigenfunction. Okay. Here I will say this is eigen. This psi is equals to, here I can say psi is equals to eigenfunction. Psi is equals to eigenfunction. And this A is equals to eigenvalue. This is the eigenvalue. That's it. It was so easy, isn't it? Yes? So easy, no? Was it something very difficult to understand? Very easy to understand. If you know differentiation, this was very easy for you to understand this, right? This is not eigenfunction, this is eigenfunction, right? So always try to understand the concepts, okay? Try to understand this. So this is what they are talking about. We have this wave function, that is psi. This wave function has two values. One is real, one is imaginary. We are not going to talk about imaginary values. We are going to talk about only real values. Real values are eigenfunctions or eigenvalues, right? Okay? Yes, bacha? And now, see, now we know everything. Now what they ask you, eigenvalue is nothing but the quantum numbers. This is azimuthal quantum number. This is principal quantum number, azimuthal quantum number, magnetic quantum number. Eigenvalues is actually the eigenvalues are the quantum numbers. That is how we know quantum numbers. We study quantum numbers. They were predicted from this side. They were solutions of eigenfunctions. Then we know eigenvalues. Now eigenvalues, we know that this eigenvalues are nothing but quantum numbers that we are going to study. But very important thing, spin is not, spin quantum number is not discovered here, or you can say is was not discovered in is not eigenvalue, is not eigenvalue. Wait, what is happening? Is not eigenvalue. Okay, this is not eigenvalue. They will ask you which of the following is the eigenvalue. Principal quantum number eigenvalue, azimuthal quantum number is the eigenvalue, magnetic quantum number is not the eigenvalue. Okay, magnetic quantum number is the eigenvalue, spin quantum number is not the eigenvalue. Very important. Next is, ma'am, what about eigenfunctions? Now, ma'am, let us talk about the eigenfunctions. For that, I need some space here. Okay, I need some space here. Now, let us talk about the eigenfunctions. Okay. Eigenfunctions are nothing but the nodes that we talk about. Okay, there are two solutions. One is radial, second is angular. Okay, if in higher classes you ever study quantum, right, we have three things in this. That is theta, phi, and we have r. Okay, these are the solutions of your quantum equation. Right, this is Schrödinger equation. You have three things: theta, phi, and r. R is the radial, right? Radial function. Theta and phi are the angular functions. Okay, so I'll write it here. This is r. This is theta or phi. Okay. Yes. You don't need to get into detail of this. Yes. Next thing that he asks you in the question paper, you have two things here. Okay. Either psi can be 0 or psi cannot be 0. Here also either psi can be 0 or psi cannot be 0. If the psi is 0, everyone, if the psi is 0, that is called antinode. That is called antinode. If the psi is, wait. This is a node, not the antinode. Yes. This is a node. Okay. If the psi is not 0, that is antinode. That is antinode. Similarly here, this is the node. This is the antinode. Now everyone, is this chart clear to everyone here? Is this chart clear to everyone here? That was not predicted out of the spin quantum number, was not predicted in this. Okay, that was calculated by some other method. Okay, bacha, very simple. We have this wave function. Wave function had two values, a real value or imaginary value. Real value has two things: eigenfunction or eigenvalue. Eigenvalue is nothing but quantum numbers, and eigenfunction is nothing but the radial and angular nodes that they ask you in paper. So now what is asked in the paper is all these things. Okay, this thing is asked in the paper. I am highlighting it. Okay, these things. Okay, these things are asked in the paper. These things are asked in the paper. Wait. Okay, radial nodes, angular nodes, N, L, M or L. Okay, these things are, yes. No, we don't need to get into that much detail. Okay, yes, just this. You just require these 2-3 things here. Now, let us talk about this one more thing, that is, what they ask you in exam is number of radial nodes, angular nodes and total nodes. Okay, this is directly asked in the exam. And total nodes. Radial nodes is what? That is n minus L minus 1. Angular nodes is L, and this is equals to n minus 1. Okay, this is the answer here. Okay, everyone, any problem? These three things are also asked in the exam. Okay, where n is the principal quantum number. You know that n is the principal quantum number, as L is the azimuthal quantum number. Yes, everyone. Yes, okay. Yes, okay. Let us talk about this now. Now let us talk about the quantum. I think we have discussed all this, okay? We have discussed everything here. I have actually discussed this in easy manner here. You just need to go through the theory part. You will be able to understand everything. Okay? Now let us discuss the quantum numbers here. Very, very important part. Most important part. Most important part. Right? Okay? Very simple way I am going to teach you this. Okay? You have 4 quantum numbers. That is N, L, M, and you have S. Okay. Now let us see. This is a principal, this is azimuthal, this is magnetic, this is spin quantum number. Right? Okay. Let us see. If you want to find the location of your friend, what you will ask? Okay, which society do you live in? Okay, you will ask firstly, which society do you live in? Okay, you will firstly ask which society do you live in. Then you will ask what is your house number? Right, what is your house number? Then you will ask, yes, what is your house number? Then you will ask, wait, or we can say that which city, okay, which city you live in. Then we will say which is the society that you live in. Right, then we will say what is the house number? What is the house number? Then we will enter their house and ask for their room. Okay, where are you? Okay, where are you? Okay, these are the 4 steps that we need to do. Right? To enter the city, that is the principal quantum number. Right? You will say, okay, which city you live in? Right? So that city can be 1, 2, 3, 4 and so on. Right? That city can be 1, 2, 3, 4 and so on. That city is nothing but basically it is called, wait, that city is nothing but what? That city in quantum we call that city as, everyone, in quantum we call that city as, everyone in the chat box, what we call that city? From this particular thing, they will ask you some question on this, okay? They are going to ask some question related to this if they ask things from quantum, right? Okay? See, N is the principal quantum number. City means principal quantum number. If you ask your principal quantum number. So, principal quantum number is nothing but it is the shell. It is the shell, okay? And it defines the size, okay? It defines the size. It gives us where is the electron. Like, okay, I belong to Delhi. Oh my God, your city is very big, right? I belong to Mumbai. Your city is very big. I belong to very simple town and village. Okay, your city is very small, right? City is big, city is small. We can identify. If they give you, this is my city, you can easily predict that this is the size of their city, right? So, to identify the size of the city is very simple, right? Okay, then is the society. Now they will tell you the society. That means they are going to ask you the subshell. Okay, subshell. Now subshell defines the shape. Okay, these subshells are nothing but S, P, D, F. We know that S is spherical, P is dumbbell, D is double dumbbell, F is complicated shape. Right? Okay, this defines the shape. If we talk about magnetic quantum number, this is going to define everyone here. Magnetic quantum number. This is nothing but the orbital. If we say px, we talk about px, py, pz. These are the orbitals, right? These are the orbitals. This is going to give us the orientation, right? This is going to give us the orientation of molecule. If we say this is px, then we say this is lying on the x-axis. If we say py, this is lying on the orbital is lying on the y-axis. That means it is giving us the orientation of the molecule, right? Okay. Then there comes spin quantum number. Now what does spin defines? It defines even the electron is sitting in that orbital in anti-clockwise or clockwise position. Right? That is the spin. Okay, spin. This is going to tell us the spin. That is minus half or plus half. Right? Okay. and it is going to tell us the clockwise or anti-clockwise nature. So here I am writing clockwise or anti-clockwise Right everyone? Till now any problem till now? Any problem here? Right? Okay. Next see what are the other questions that are asked from this. Very important thing. What are the other questions that are asked from this? Yes, sure. Even JEE students can join this because it's a very important session. Okay. Yes, all these things are asked in JEE as well. So now let us talk about how you calculate n. N can be everyone. N can be 0. N can be 1, 2, 3, 4 and so on. Any integer, right? It can be value of principal quantum number. Talking about the azimuthal quantum number. Everyone here, what is the value of azimuthal quantum number? That will be equals to 0 to n minus 1. Right? And always remember, this can never be, L can never be greater than or equals to n. L can never be equal to. So many questions are asked from this particular statement that azimuthal quantum number can never be greater than or equals to principal quantum number. Never. It will always be 1 minus. Okay. Let us talk about magnetic quantum number here. Magnetic quantum number is nothing but is equals to minus L2. I'm writing it here. M is equals to minus L2 plus L. Okay. Minus L2 plus L. Right? Okay. This will be minus L2 plus L. And spin will always be equals to plus half or minus half, clockwise or anti-clockwise. That's it. These are the values. Okay? Understood this? Any problem till now? Yes, bacha, any problem till now? Yes, understood this? Now, few formulas regarding this, that number of orbitals, these are the orbitals, number of orbitals equals to either n square or 2l plus 1. If they have given you the value of L here, that will be 2l plus 1. If they have given you the value of n here, that will be n square. Okay? Number of electrons will be double of number of orbitals, right? Number of electrons will always be double of number of orbitals. Just you need to remember these things. Yes, bacha, namaskaram. Yes, okay. Bacha, yes, bacha, because this is an English channel, that's why this is an English. Yes, okay, understood this everyone? Any problem till now? Yes, bacha, this is going to help you in JEE as well. Yes, any problem? If you don't have this thing in JEE, then it will not help you. If you have this topic in JEE, this will help you. Yes? Thank you, bacha. Thank you, Aarthi. Now, any problem in this particular thing? Now, let us discuss one thing, okay? Let us discuss n is equals to what can be the value of this. Okay, I'm writing it here only. L can be S, P, D, F and so on, right? And M can be like Px, Py, Pz, or you say D, X square. D has 5 and F has 14, right? F has 7. These are the orbitals, okay? Now let us see. If they tell you that you have just two things I am going to do. If you have n is equals to 4, okay? For n is equals to, or we can just directly jump to the questions, okay? We can directly jump to the questions here, right? I think we should do the questions, and that way we will be able to solve so many things. Yes, everyone? Is this understood? Everyone? Yes? Okay? No problem? Okay. Let us move to the questions, okay? Let us move to the question part. All the theory you can read it. This is the same thing that I told you, that finding the electron, this is the wave function. What is orbital? Orbital is px, py, pz, where the electron is actually present. Okay, orbital is the location in space in which probability of finding electron is maximum. Okay, so this is s orbital, p orbital, d orbital, all these are orbitals, right? Okay, next we have all these things are given for the size, shape and orientation. This is for n, this is for l, this is for m, right? Then we have probability of finding electron along certain direction, then along others. Okay, shape and orientation, that means they are talking about what this shape means. They are talking about p, right? Orientation means they are talking about px, that here the finding electron along x direction is maximum. Okay, yes, okay, perfect. Now next that each orbital is designed by 3 quantum numbers labeled as NLM, right? And then we have the spin quantum number, right? These are the 4 sets here, right? 4 quantum numbers and electron address. We are going to find this, right? This is the n shell. N is the shell number, right? This is the shell number, and shell number has how many electrons? Electrons are going to be the double of the number of orbitals. Orbital are going to be n square, so number of electrons are going to be 2n square. Okay, we have already done this here. Okay, see this, we have already done this here. Already done this. Number of orbitals is equals to n square. Number of electron is equals to 2 into number of orbitals. That is 2n square. Okay, I have made it very simple for you. Right? Okay. Now, next is azimuthal quantum number. The values will be 0 to n minus 1. Right? The values will be 0 to n minus 1. For example, if I am talking about an orbital, if I am talking about n is equals to L, it will have how many values of L? That will be 0, 1, 2 and 3. Right? This means this belongs to S, this belongs to P, this belongs to D and this belongs to F. Right? Okay? Understood this? Now, this S is further. This M will be, M is going to be, if I talk about 4 sections here, okay, for L is equals to 0, for L is equals to 1, for L is equals to 2, for L is equals to 3, right? So how many things it is going to have? It is going to have how many orbitals? These are the subshells, okay? These are the subshells. So L is equals to 0. That means M is going to be, M is from minus L to plus L, to plus L. So M is also going to be 0. That is why S always have just one orbital, just one box, right? If we are going to talk about, L is equals to 1, that means M is going to be minus 1, 2 plus 1. That is M is going to be minus 1, 0 plus 1, right? This is going to be the value of M here, right? So that is why it has 3 boxes here. That is Px, Py and Pz. And usually always Pz is equals to 0. In this case, Pz is equals to 0. Px and Py can have positive or negative values. Okay, Pz usually is fixed to 0. Okay, yes. Okay, next thing that we are going to tell here is L is equals to 2, M is going to be, this is S, this is P, this is D and this is F, right? M is going to be minus 2 to plus 2, that is, it is going to have 5 boxes here. Okay, that is why for D we always draw 5, that is minus 2, minus 1, 0, plus 1, plus 2, right? And for F we have how many? We have M is equals to minus 3 to plus 3. That is how many values? How many values? 7 values here. Right? That means 7 boxes here. Okay, 1, 2, 3, 4, 5, 6, 7. Right? From minus 3 to plus 3. Right, everyone? Okay? Yes? Any problem? Yes, bacha? Yes? Okay? Or if they ask you directly how many orbits it could have, you will directly write how many orbits. Orbits can be 2n square, that is 2 into 4 square, right? That is 4 for 16 to 32. No, 2n square, just orbits is n square. Electrons are 2n square, okay? This is to give me 4 square, that is 16. Let us calculate. If it has 16 orbitals, 1, 2, 3, 4, 5, 6, 7, 8, 9. This is 5, 6, 7, 8, 9. 10, 11, 12, 13, 14, 15, 16. Yes, it does have 16 electrons, 16 orbitals. Yes, bacha? Okay? Yes? Everyone here understood? No problem here? Yes, should we start the questions now? Everyone, bacha, shall we start the questions now? Shall we start the questions now? Yes? Okay, perfect. So these are the values of L is equals to 0. We have completed this. We have completed this as well. Now this is the angular momentum. That is L is equals to L in terms of azimuthal quantum number. That is under root L plus 1 h by 2 pi. Right? Okay. This is the angular. Right? This is in case of quantum number, quantum model, not Bohr model. Right? Okay. Next, bacha. Oh my god, I just told you the answer. Right? So, the orbital angular momentum of electron is 2s. This is the orbital angular momentum. They are asking you orbital angular momentum. That means just apply the formula here. 2s means you have n is equals to 2. S means S0. S is 0. This means L is going to be, for S, L is going to be 0 here. Right? S, P, D, F, 0, 1, 2, 3. Okay, what we have? S, P, D, F, 0, 1, 2, 3. Okay, and so on. Right? So this is going to be 0. Just put the value of this. And if L is 0, momentum is also going to be 0. So answer is going to be 0 here. Right? Next is quantum numbers. This we have done in case of, if we are given the value of azimuthal quantum number, then how do you identify the number of orbitals there? You will see, if we talk about that we have L is equals to 3. That is SPD. F 0, 1, 2, 3. They are talking about F orbital. F subshell. For F subshell we have 7 orbits. We know that. We have 7 orbitals. But to put that into formula, we will have 2L plus 1 number of orbitals. That is 2 into 3 plus 1. That is 7 orbitals. Right? That is 7 orbitals. This is what they are talking about. We have already done this formula as well. Okay? Already done this formula. Now let us go through the shapes here. This is the shape for p orbital. For s orbital, this is spherical shape. For p orbital, this is px along the x-axis, py along the y-axis, pz along the z-axis. This is having dumbbell shape. Okay? Like a dumbbell. Right? This is having dumbbell shape. Now, about the d orbital, this is having double dumbbell shape except for dz square. dx, dxy, dyz and dzx are between the axis. dz square, dx square minus y square are along the axis. Okay, these are along the axis. Right, that's it. One thing about Z, this is the Z, okay, this is having dumbbell shape and the electron clouds in this Z, okay, Z-axis it has electron clouds, okay, this is the shape. They will ask you one question, that is your PYQ, that which of the following have different shape. dz square have the different shape. Yes, these are between the axis, the x square minus y square is along the axis, but the shape is double dumbbell only. Right, the shape is same. There is difference in the orientation. The shape is same now. They're talking about the shape, not the orientation. Right? Okay. Next is bacha. These are the values already done. Right? Spin quantum number either plus half or minus half. Right? This is clockwise, anti-clockwise. Either clockwise or it is anti-clockwise. This is not eigenvalue. Now, spin quantum number, this is the spin quantum number, that is in the value, we'll put the value of s here. That is under root s plus 1 h by 2 pi. Same as comparison to angular quantum number. Right? Okay? Now, which of the following d orbital will have electron density along the axis? Along the axis, which has along the axis, okay? This does not have along the axis. This does not have along. This does not have along. This does not have along the axis. Here nothing is true. All the answers are incorrect. Okay, there is this should be z square. Okay, this should be z square. Okay, if in this case zx, this is xy, not along the axis. This is between the axis, between the axis, between the axis, between the axis. Right? Only dz square and dx square minus y square are along the axis. Right? So this is going to be the right answer here. Next is an electron is in one of the 3D orbitals. Give the possible value of NLM. 3D orbital, bacha. Now 3D orbital. For 3D orbital, we have n is equals to 3, L is equals to 0, 1, 2, SPD. That is 2. Okay, the value of L is going to be 2 here. That is going to be 2 here. Right? Give the possible values. Okay, what is the value of m? M can be minus 2, minus 1, 0, plus 1, plus 2. These are the possible values of m here. Yes, everyone? Very good. Yes, that was the error. Okay. Now, how many subshells associate with n is equals to 4? For n is equals to 4, how many subshells associate with it? Yes, bacha, how many subshells? Subshells they are talking about. How many subshells? For n is equals to 4, we can have L is equals to 0 to n minus 1, that is 3. So it will be 0, 1, 2, 3. So the number of subshells are going to be same as the value of n. The number is going to be same. The values are going to be different here. Okay. So we have answered this. This is the A part. B part is how many electrons will be present in the subshell having ms value of this. Okay. How many electrons will be present in the subshells? How many electrons? Okay. Having this n is equals to 4. So the number of orbitals or number of electrons, you can say number of electrons for n is equals to 4 is going to be 2n square. That is this. Okay, and the number of electrons with half spin is going to be by 2, because out of in every single orbital you have 2 electrons. One is this, other is this. This means both the electrons are of opposite spin in one orbital. Here what we can say that the number of electrons present in n is equals to 4 will be equals to n square. Okay, or I will write it as this. Number of electrons will be equals to 2n square. Number of electrons with minus half or plus half spin will be equals to 1 by 2 to n square. That is n square, that is 16. Understood this? Yes, bacha? Yes. Next we have how many electrons in an atom may have following quantum numbers. How many electrons in an atom may have following quantum numbers? Which have following quantum numbers? Yes, n is equals to 4 ms this, right? This means they are talking about number of electrons, again 16 will be the answer. How? Because number of electrons is going to be 2n square, right? And the number of electrons with minus half spin is going to be n square. That is 16. And the number of electrons in n is equals to 3 and L is equals to 0. That means s orbital they are talking about, right? S subshell they are talking about, out of which we have only one orbital, right? This is 3s. 3s is going to have 2 electrons only. 3s is going to have 2 electrons, right? Yes. Now, next question. Nodes and antinodes already done. Yes, already done. When psi is equals to 0, that is the node, where there is no probability of finding the electron, right? Angular node is when in case of theta and phi, there are no probability of finding the electron. These are radial nodes. Okay, it presents a sphere at some distance from nucleus where probability of finding the electron is 0. Through an orbit, it represents a plane passing through. Okay, plane will be defined by angles, that is theta and phi. Okay, where probability of finding the electron is 0. right? The formulas we have done. For example, these are the radial nodes. This is the distance from the nucleus. Distance from the nucleus. This is the plane where the chance of finding the electron is going to be 0, right? Okay, and this is the formula of radial nodes, angular nodes, and this is the formula of total nodes. Okay, already done this. Yes, bacha. Next is the energy. For energy calculation, two things we have. For hydrogen atom, more is the number of value of N, more is the value of the energy. Okay, for hydrogen atom, single electron species, energy is directly proportional to N. Okay, no N plus L rule is applied here. 2s and 2p is going to have equal energy here. Okay, that means the energy of 1s, then 2s and 2p is going to have equal energy. 3s, 3p, 3d is going to have equal energy. 4s, 4p, 4d, 4f is going to have equal energy because it is not dependent on N plus L. Right? Okay. Next is the energy of orbital. For other than one electron species, we have energy is directly proportional to N plus L rule. Okay, that is N plus L rule. More is the value of N plus L, more will be the energy. Right? Now, let us see this thing here. How to calculate how to learn the energy. Right? Very simple. This is S, P, D, F. Okay, S, P, D, F. This is 1, 2, 3, 4. Now write it down. Write it down. Write here. Firstly, write here. Wait. Okay. Firstly, write here, everyone. This is 1, 2, 3, 4. Okay, what you are going to write here? Firstly SS, then PS, PS, then DPS, DPS, then FDPS, DPS. Right, just write it down here. That is SS, PS, PS. Right, then DPS, 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 DPS. Then you have FDPS, FDPS, FDPS. You can write it more. Right, then firstly write 1, S is going to start from 1, P is going to start from 2, D is going to start from 3, and F is going to start from 4. Okay, then just complete it. This is 1s, 2s, 3s, 4s, 5s, 6s, 7s. Okay, then you have 2p, 3p, 4p, this is 5p, this is 6p. Then you have D, 3d, 4d, this is 4d, this is yes. Okay, we have completed it. You can also write it further, that is S, FDPS, then again FDPS. Okay, then you have 7s, this is 8s, this is 4D, this is 4D, this is 5D, this is 6D, right? And this is 4F, this is 5F, and this is going to be 6P, this is going to be 7P, right? Okay, everyone, this is 8S. Any problem here? These are the increasing order. Okay, ma'am just joined. We are going to end the lecture now. Okay, you can see the recorded after that. Right, this is the increasing order of energy. Or I can just write it here. This is the increasing order of energy. Increasing order of energy. Right? Increasing order of energy. Right, everyone? Yes? Okay. Ma'am, L plus N rule, that rule is applied just for, except for hydrogen-like species. For hydrogen-like species and hydrogen, N plus L rule is not applied. Okay? Yes? Perfect. Understood this? Now you don't need to cram this. Okay? What you need to do? The trick is SPDA 1, 2, 3, 4. Firstly SS, then PS, PS. Then you have DPS, DPS. DPS, DPS. Then you have FDPS, FDPS. FDPS, FDPS. Okay, just write start S from 1, P from 2, 3, D from 3 and F from 4. Yes, bacha? Can we use N plus L rule here? Yeah, this is actually N plus L rule only. Okay, this is okay, by using, you can use N plus L rule, but this is after applying the N plus L rule, this is the order of energy, right? After applying the N plus L rule, right? After applying N plus L rule only, we got this order, right? Okay, this is the result of N plus L rule. Yes, bacha? Okay, yes. Now, let us do the questions here. After that, we are going to do the electronic configuration, some rules, and chapter finished. Yes, orbital having 3 angular node and 3 total node. That means L is going to be 3. Total node is also 3. Total node means N minus L is also 3. N minus 1 is also 3. That means N is equals to 4. Right? So this is 4F. This is 4F orbital. 3 means F. Right? This is 4F orbital. Yes, everyone? This is angular. Angular node means they are talking about L here. Number of angular nodes is equals to L. Number of radial nodes is equals to N minus L minus 1. Total nodes is equals to N minus 1. Just put the values here. You will get N value, L value here. And this symbolizes 4F orbital. So answer is C, 4F orbital. Yes? Okay? Very easy, very easy, very easy. Next we have rules for filling electrons. So we have 3 rules for filling electron. Aufbau principle, Hund rules, Pauli exclusion principle. Very simple rules. Very simple rules. Let us go through this. Pauli Aufbau principle. Okay? Firstly, let us understand Aufbau principle. Aufbau principle says that if you have multi-electron system, electrons will be filled according to the N plus L rule. Okay, you're going to fill the electrons according to N plus L rule. Firstly, you will fill the electron with minimum energy going to the maximum energy. Right, so the energy is decided on this. The word Aufbau in this is okay. In the ground state of the electron, orbitals are filled in order of their increasing energy. This is the main highlight here. That electrons are filled according to the increasing. Firstly, if we see this here, how electrons will be filled here? Firstly, we'll have 1s2, 2s2, 2p3. Okay, this is how it will be filled here. Right? Okay. Next, bacha, next principle that we have, that is, this is according to the rule. Okay. Now, if you have N plus L different, then you will fill the N plus L which has less value of N plus L, then more value of N plus L. But if N plus L is same, right? If N plus L is same, in that case, more is the value of energy, N, more is the value of energy. Okay? That will be proportional to N here. Okay? As we know from the hydrogen law. Right? Okay? If you have N plus value is same for N plus L, in that case, that will be dependent on the value of N. Yes, everyone? Okay? Yes? Easy? Easy peasy? Now, next is Pauli exclusion principle. We are going to exclude something. Whom we are going to exclude? The third. Okay? We are not going to do extramarital affair here. Okay? That means in one orbital, only 2 electrons will be present. And as you know, opposite attracts, right? That is why we say in a couple, we have 2 opposite. One is introvert, one is extrovert. This is what happened, right? So one is positive, other is negative. One is having plus half spin, second is having minus half spin. This is what Pauli exclusion principle means. That we are not going to fill the third electron here. We are not going to fill the third electron here, okay? According to this, no 2 electrons in an atom can have same set of 4 quantum number. Ma'am, what is this saying? They are saying N can be same, L can be same, N can be same, but S cannot be same. If we say everything is same, but S will not be same. That means, now I just got one example, but I think I will be trolled for that, and that is not a good example, so I will not give that. Okay, so you think what I was thinking. Okay, I will give you that example in Telegram channel. Right? So can also be stated as only two electrons, right? Only two electrons may exist in same orbital, and these electrons must have opposite spin. And the spin should be opposite, right? Third electron cannot be filled. This is represented by square box. They are saying the orbital is represented by square box, and the electrons can be represented by this arrows. This is what do you remember from this side? This is the sign of a mobile data, isn't it? For others, this is mobile data. For us, this is what? Electrons with opposite spin. What to do? This is our life, right? But we love electrons more than mobile data. No, I'll give you in the Telegram channel. Right? Okay. Next is, bacha, we have possible number of orbitals is subshell. Possible number of orbitals, bacha, this is what? Possible number of orbitals is equals to, we have subshell, that is 2l plus 1. Right? Okay. This is number of electrons is 2 into 2l plus 1. Simply apply the formula, you will get the answer. Right? Okay. Now, just apply the formula, you will get the answer. Done these two formulas. Okay. We have done these two formulas. Now, ma'am, where have we done? We have done that in formula sheet of quantum numbers. Right? That number of orbitals in case of n is n square, and in case of l it is 2l plus 1. And number of electron will be double of that. Okay? Yes, bacha? Yes. She is saying it should be half arrow. No. You can also represent it like this or this. Same thing. Right? Same thing. Right? Okay. Next is Hund's maximum rule of multiplicity. Now what is this? See, what we are saying, that you have to fill the electrons one by one. Okay? You have to fill the electrons one by one. You cannot fill the electrons like this. You cannot just form the couples. Come to the family or just join the school. Then you not making friends. You are not making friends. You're just making these couples and all. Right? You just want to date someone. No, that is not like a good method. Okay? Firstly, make friends. Because friends, that couple thing is temporary, but this friend thing is very like, this is a permanent bond. Like when you have good friends, that is the most beautiful bond that you will have. So that is why what we say, do not form couples. What chemistry says, chemistry gives you life lessons, okay? There is not form couples here, okay? Form friends here, okay? Firstly, one by one. If you have satisfied with the friends, okay, I have enough amount of friends now, then you can couple with someone. Only then you can couple. Right? Okay. One by one. Firstly, all the orbitals will be filled with one electron. After that, the other pairing will be done. Yes? Okay. That means the orbital having same energy. Degeneracy, same energy. Friends have same energy. First you will form friends. Okay. Yes? Friends have the highest. Degeneracy means same energy. Has, okay, d orbital, p orbital, px, py, pz has the same number of energy. Dx, all the orbitals of d subshell have same energy, right? Okay, yes. Now, let us do the questions here. Two electrons occupying the same orbitals are distinguished by, how they can be distinguished? Having occupied the same orbital, they are in the same orbital. That means n is same, L is same, M is also same. They will be distinguished by spin quantum number will not be same. That means that will be distinguished by spin quantum number. I am talking about true friends which have same energies. Okay, you make this if S is making bond with p orbital. Now what you have to do with p orbital? Make friends of same energy, of same mindset, right? Okay, then you will be successful in life, right? Your company matters a lot. So good that your best friend left you, because who leave you are not your friends, right? Next is okay, electronic configuration. Very simple. You just need to fill the electrons here. Okay, let us do the electronic configuration here. Let us do the electronic configuration for few atoms here. For example, any random I am going to pick up here. Okay, any random I am going to pick here. Right? For example, I am talking about nitrogen here. Nitrogen is having 7. So it will be 1s2, 2s2, 2p, this is 4, 5, 6, 7, 2p3. If I am talking about oxygen, oxygen is 8, that will be 1s2, 2s2, 2p4, 4, 5, 6, 7, 8. Right? Okay, this is how it is done. Or we can also write it as this is S, this is P, this is P, this is also S, S, and this is P. Right? This is 1s, 1s, 2s, 2s, 2p, 2p. Okay? Here how are you going to fill the electrons? 1, 2, 1, 2. Degeneracy, no? Degeneracy, couple it. Degeneracy, couple it. Anyway, they are very introvert. Okay? Very simple. Very introvert. Now, they are three friends. Okay? Firstly, they are going to meet. Okay? Now, they don't have any couple. No pairing. Just 3 electrons. Okay, happy. Here, I have 4 friends. Okay? So, 1, 2, 3. So, 1 will be paired here. Right? Okay? That is this. This is how you are going to do the electronic configuration. But the electronic configuration also, we have an exception. These are the electronic configurations. Right? We have electronic configuration. They're talking about nitrogen, that this is half filled, that is why it is very stable, right? It has stable configuration. Now this is the neon, that is the noble gas configuration. It has all the electrons, that means the octet is complete. Noble gas configuration means the octet is complete, right? It has 2 electrons, 6 electrons in p orbital, very happy, okay, very happy. Now let us talk about few exceptions. This is how you fill the electrons. Firstly, fill single, then double. Okay, first you fill single, then 1, 2, 3, then 4, then 5. Okay, 6 will be done. How? 1, 2, 3, 4, 5, 6. Okay, this is how it will be done. Right, bacha? Now let us talk about the exceptional electronic configuration. Okay, let us talk about the exceptional electronic configuration. Wait. Okay, now what they are saying here, that if you want to write the configuration of sodium, what is sodium? That is having 11. 1s2, 2s2, 2p6. Okay, then 3s2, 3p. 2, 3, 4, 6, 7, 8, 9, 10. This is 3p1. He is saying this is having 1, 2, 3, 4, 6, 7, 8. This is the electronic configuration of. This is the electronic configuration of what? This is the electronic configuration of neon. Right? So what you can write here? Neon 3p1. This is what they are saying, that you can write it here. Right? No, 6, 7, 8, 9, 10. I am writing here. I think I need to have dinner now because my brain is collapsing now. Right? Okay. This is 10 electrons. So this is neon and this is 3s2. This is 3p1. Okay. This is how you can write it. Okay. Similarly, they are saying for argon, you have this electronic configuration. For example, they are saying you are writing the electronic configuration of potassium. Potassium, you know that the atomic number is 19. This will be the electronic configuration. And this thing, this whole is the electronic configuration of argon. You can write it argon 4s1. Similarly, here you can write argon 4s2. Right? That is simply how you can, you will be saved in writing the so many electronic configuration, 1s2, 2s2, 2p. Instead of that, just write down the electronic configuration of previous noble gas. Right? Okay? Yes. Now we are going to do the exceptions of. Now let us do the exceptions of. Yes. Copper and chromium. Copper and chromium. Chromium and copper. We are also going to do it in B block as well. Right? So Ker means 24. It has electronic configuration 24. It has atomic number 29. Right? Okay? Saktiv, Karman, Fico, right? Then you have, this is 24, this is 29. This is going to be, we will again do it in the D block chapter, okay? We are going to repeat this. Now, let us talk about this electronic configuration. This will be argon 18, and then you will have 4s2 3d, this would be 4, right? And this should be argon, this is 4s2, that is 18, argon has 18 atomic number, 18, 20, 24, 18, 20, then you have 3d, 9. So they are saying that this will be exceptional here, because after gaining one electron from this, it will be converted to 3d5, which is half filled. So half filled is more stable, right? If it can gain electron and convert it into half filled, then it will prefer that, right? So the exceptional electronic configuration here also will be 4s1 3d, 4s1 OCD of blackboard I have, right? You can see that clearly. 4s1 3d 10, okay? 4s1 3d1. These are the exceptional electronic configuration. Now why this happened? This is because of the exchange energies and symmetry, right? Because in this you have half filled is more stable. Why half filled and fully filled are more stable? Because half filled and fully filled have stability, one thing, stability, what I am saying, they have more symmetry, right? It has this kind of, okay, this is 1, 2, 3, 4, 5. You will see the exchange energy, that means exchanging the electrons from one orbit to the other orbital. It has symmetry, it has symmetry, right? Again it has symmetry, right? Again it has symmetry. You can clearly see ma'am has OCD of blackboard, okay? Ma'am usually raise these things so that she can write it beautifully, okay? So now this is half filled, this is fully filled. It has symmetry, that is why it is more stable. The exchange energy is more, okay? The electrons can be exchanged here, the electron can be exchanged here, then here. It has more exchange energy. Similarly with this, similarly with fully filled, right? That is why they are more stable. That is why they are more stable. So these are the electronic configuration. Now let us see the electronic configuration of Fe. Now there's electronic configuration of Fe positive, 2 positive, 3 positive. Very simple. Now the electron is abstracted from 4s first, and after that it will be extracted from the, these things we are also going to use these things in the D block. Coordination chemistry is dependent on this. If you don't know how to abstract the electron, you won't be able to do the coordination chemistry, you won't be able to do chemical bonding still you can do from this, right? But you won't be able to do coordination and D block. Not possible without this. All the answers lies here, okay? All the answers to your questions lies here, right? So here we have, this is argon. Electron will be abstracted from 4s firstly. That means 4s 1 3d 6, right? Again, electron will be abstracted from 4s1, right? That is 0 3d 6. Again, now 4s is empty. Now electron will be abstracted from 3d. So this is 4s0 3d5, right? Okay, bacha? Yes, perfect. What problem? Due to symmetry and energy. Which problem you have? Okay, now this is chromium and this is copper. There is exceptional configuration because of half-filled orbitals, right? Half-filled and fully filled. Why so? First is symmetrical arrangement, symmetrical distribution. Second thing here is the exchange energy. Because of the exchange energy is more for symmetrical thing, for half-filled and fully filled. That is why it has more stability. Yes, bacha? Any issue? Yes, understood this? Yes, bacha? Okay, let us do some questions and then we are free. An atom of an element contains 29 electrons and 35 neutrons. Deduce the number of protons. Now what they are saying, deduce the number of protons here. We are just left with few questions, okay? Very important questions here. Very important questions, okay? Oh. Now, everyone, an atom of an element contains 29 electrons, 35 neutrons. Deduce the number of protons. Number of protons is equals to the number of electrons, that is 29, right? Then we have the electronic configuration of the element, that is equals to number of protons. This is, they are talking about copper here, right? That will be argon, 4s1, 3d10. This is the electronic configuration that they are talking about. Okay? Yes, bacha? Everyone here? Okay. Next is 4f, 4d, 5d, 5f, 6p orbitals are arranged in the order of decreasing energy. The correct option here is, everyone, what is the correct option? 4s, 5p, 5f, 6p orbitals are arranged in the order. Decreasing order is to write the decreasing order. In this case, just apply the n plus L rule. Okay? Energy is directly proportional to n plus L. And if not n plus L, if n plus L is same, energy is proportional to n. Right? They have not talking about hydrogen atoms, so this will be applied. If they talk about hydrogen atoms, then energy will be directly proportional to n only. Right? Okay? Yes. Now what will be the answer here? Maximum energy, Vicha. What will the answer here? Everyone here. This is 3, 5, 6, 7, 8. Okay, this is 8. This is 5f is equals to 8. 5f is equals to 8. 6p is equals to 6, 7. Right? 4d is equals to 4, 5, 6. And 5p is equals to 5, 6. Right? So they have same energy. So this is, they have same n plus L. So more the value of n, more is the energy. Right? More the value of n, more is the energy. So this will have more energy here. Right? So the value will be 5f, then 6p, then 5p, then you have 4d. Right? 5f, 6p, 5p, 4d. B is going to be the right answer. Yes? Okay? B is going to be the right answer here. Next, bacha. How many electrons can fit in an orbital of n is equals to 3, L is equals to 1? L is equals to 1. See, I do it with my fingers, okay? S, P, D, F. 0, 1, 2, 3. Okay? S, P, D, F, 0, 1, 2, 3. Right? Okay? Yes? So, how many electrons in the orbital? N is equals to 3, L is equals to 1. L is equals to 1 is for P. So, this is talking about 3p. For 3p, we have 3 orbitals. For 3 orbitals, we have 6 electrons. Right? We have 6 electrons here. Right? For 3p, we have 6 electrons here. Oh, wow, what happened? How many electrons can fit in an orbital? So easy, yaar. Acha, they made us, they made popat out of us, okay? So, they are playing games with us. Acha. So, rocket can fit in an orbital. The answer will always is going to be 2. Why? Because they are talking about one orbital. They are not talking about subshell. They are just talking about one orbital. Even if they ask anything here, the answer is going to be 2 only. Right? So, you need to, save yourself from these kind of questions. They're so easy. Right? So easy. Asked in 2016. Right? The examiner must be laughing at this question. Okay. Let's see what is the presence of mind of these students. Yeah? Chalo. Next we have the electronic configuration of Cu. Very easy. What is the electronic configuration of Cu? Acha everyone? This is the electronic configuration of Cu. So I am going to write it here. Okay? This is the electronic configuration of copper. Right? B is the correct answer. Next we have which of the following configuration is correct for iron? For iron, that is atomic number 26. For 26 we have argon. This is argon, this is argon, this is argon. Right? This is argon. After argon, this is electronic configuration of argon, right? After argon, what we are left with? 4s2. 4s2, we are left with argon, 4s2, 3d6. Okay, that is going to be the answer. 4s2, 3d6. No, this is going to be the correct answer. D is going to be the correct answer here. Yes, everyone? Yes? Okay, due to lack of mind. Due to lack of presence of mind, not mind. Yes? Okay. Next is indicate the number of unpaired electrons. Unpaired electrons you have to indicate. Just write down the electronic configuration of all the atoms here. Just write down the electronic configuration of all the atoms here, okay? All the atoms, write down the electronic configuration. It has 3 electrons unpaired. It has 2 electrons unpaired. It has, in 3D, this will be 1, 2, 3, 4. This is 5 electrons unpaired here. And 1 electron here, that is going to be 6 electrons unpaired. This will be fully filled, no unpaired electron, no unpaired, wait. Why 4 unpaired electron here? Okay, yes, 6, okay, they are talking about 3D, right? So that will be 1, 2, 3, 4, 5 and 6. So 4 unpaired electron here, right? And here they are talking about, this is fully filled, this is fully filled, fully filled. So no unpaired electron here, right? Okay, simple, very simple. Just write down the electronic configuration. Remember the atomic numbers. Write down the electronic configuration. That's it. Okay. Yes, bacha. Okay. Okay. Santosh, that's motivation should be intrinsic. Not at this time when you have just 2 months left. If you need extrinsic motivation to study, then I am very scared for you, right? You know, just see your date sheet, just see your calendar, mark the dates that are left for 5th of May, and then you will have your motivation. Because if now you're not, motivating yourself, that thing is not coming from your heart that I need to study. There may be demotivation. There may be times when you will feel like, okay, I'm not able to do anything, but that is very normal. But otherwise, you should always feel motivated that, okay, I have to do this. There's just every single day, every single minute is very important for you, right? That is why I have carried all the important points, detailed points of structure of atom in just one lecture. Why? What is the reason? Because I don't want to waste even a single minute of you. Because every single minute, someone else is studying, going in that race. If you want to be a part of this race, then you have to study. There is no short trick of that. No short trick of that. Now you have to. Okay? Next, bacha, okay, we have completed this. Now everyone see this very carefully, what we are going to teach you now. Now see this, important links for your NEET 2024 preparation. Now where are these important links? Let me tell you that in the comment section. Let me tell you in the description box itself. Now next thing is, NEET city, in your new city, what I am saying, Vedantu learning center now in your city for all the students, right? Not for the students who are droppers, right? They must clear their NEET now, right? For them, crash course is going on for 2 months. But for the students who are preparing, who are in 11th class and they want to have that offline experience, right? Now, you just need to go through the calendar, go through the locations of Vedantu center, right? And now what will happen that if you have offline center, then you can go to that offline center and avail more services, right? Okay, now let us see this. So what all will be taught in that? So hiding interactive classes, class recordings and notes, pedagogy, app for unlimited practice, continuous feedback, buddy recorded lectures, right? So now another one most important question is that, ma'am, is that in our city or not, right? For that, these are the cities where you can say in Punjab, that is very close to my house, that is Patiala. You will see if you're from south side, there you will see Tamil Nadu, Andhra Pradesh, Telangana. We have Hyderabad, Vishakhapatnam, Vijayanagar. Okay, then Gunur, and then Chennai, Kotambur. I'm not able to pronounce the city name. I'm so sorry about it. Right? Then we have Karnataka here, Maharashtra here. I think most of the students who are watching this lecture are from this region, this region, this region, this region, this region. because these region students watch English lectures, right? And if you're from north side, you have center in Rajasthan, NCR, Delhi, right? Very simple to go there. Then you have centers in Punjab, then Bihar also we have centers, right? You can join the offline classes as well, right? I would highly advise you that. Highly advise you that, because the experience is different, right? We try our best. We try our best to have that interaction with you through like this platform. But also, if that city is close to your house, then I would highly advise you to join that, right? Because offline experience with quality content is a rare thing, right? Okay, then bacha, for that also, all the students who are thinking about the financial support, for financial support we have the scholarship test that is going on, that is IVSAT 2024, and I highly advise all of, if you are living near to the city of Vedantu center or not, you must give this test, because you will eventually, you know, if you want to buy some course, some crash course or anything, right, and you want to deduct the financial, like all the expenses from that, for that we need your IVSAT answer. We need your IVSAT registration, and you need to give the test for that, and according to your rank, that thing will be decided if you deserve the scholarship or not, right? So I would highly advise you, if you have prepared something, so please give this test. Okay, so now all the links, ma'am, how it will be. Okay, so and next thing is, yeah, this is an offline center. If you're living nearby some offline center, in that case, you can, firstly you can give test from anywhere, but if you give test from offline center, you will get 2x amount the scholarship here, right? Okay, yes, yes, okay, perfect. Now Shreyas sir also went to the offline center, I think in Pune, right? If I am not wrong, Pune. Right, that experience was different. I also want to meet you guys. I also want to visit some offline center. So also do write it in the comment section. What is your city and where you want to meet me? Okay, do write it in the comment section. Yes, okay. Then bacha, this is our Telegram channel. That is totally, you know, all the links, all the free of cost things are provided to you in the Telegram channel. So do join that Telegram channel as well. Now just wait a minute. I have something for you. Just wait a minute. Just wait a minute. Okay. Okay. See this? These are the important links. Very important links. Firstly, you have this NEET magic kit. Listen to this very carefully. You have this NEET magic kit. Okay, just go through this, and you then fill your form. Wait. I don't know why not. It is not taking that. Okay, I want to show you that, because this is very important for you. Just give me a minute. Don't worry, we have the solution to everything. We have the solution to everything, okay? Your ma'am has the solution to everything here. Without sharing my number, I will tell you how to open the magic kit, okay? Ma'am is doing some technical stuff here. Okay, yes. I think now I will be able to open it. Just a minute, just a minute. Now see this, this is the magic kit that I was talking. Let's pray to this God. Yeah, we won. Yes, yes, this is magic. So now let us see what is all in the magic kit. See guys, You have this physics syllabus, chemistry syllabus, this syllabus. Now, you have NEET previous year questions in this magic kit. Question paper 2023, 2022, 21, 2020, 2019 for all the students. This is must. This is must. You must solve the, you are just 2 months left here, right? Okay. Now you have just 2 months left. Now what we are going to do? We must solve the PYQs here. And what if you are able to solve the whole question paper? That would be great. Take the question paper as your mock test, right? And solve it yourself. You will be provided with the solutions as well. Okay. If I talk about the 2021 question paper, these are the question paper. Okay. This is the answer to that. Okay. This is along with the solution you are provided with the question paper. Okay. This is totally error free. Now, next thing, bacha, that we are going to do here. Firstly, you have previous year question. Now, this is NEET previous year question. Wait. This is, yeah. So, this is for code A, for code E, code P, code W, code N. Okay, different codes. We have different question paper along with that. Now, with question paper 2017, then we have question paper 2016, then we have question paper 2015. Means all the question paper in all the codes before 2017, right? That was code wise. And if there is any different phases to that, okay, that is also given to you. All the question paper of 2016 is provided to you. All the question of 2015 is provided to you, right? So everything is provided in the magic kit here. Just need to click on that, right? Okay. Next, bacha, we have, this is the Vedantu Learning Center. Wait. This is the treasure box, and treasure box is also very important for you. Now, for this treasure box, go to the chemistry part here, and then any chapter. For example, we have done the states of matter now. Go to the PYQ test here, right? Go to the PYQs test here and give the PYQs test. Okay, start the test and give the test here, right? This is the PYQs test that you can give, right? Okay, right? This is the first thing. Second thing is NEET PYQs. If you do not want to give the test, but you want to, go through the PYQs itself, right? You can go through this. That is totally free of cost. Right. Next, you have CBSE questions. So these are the CBSE questions. Go through this. So these are the CBSE questions of that. I have just opened the CBSE questions from some basic concepts of chemistry. These are the CBSE questions from from structure of atom. And for NEET, you need to always go through the PYQs and NCERT question. That is must. That is must for you. Right. Next, bacha. Next that you have. And if you are so lazy, if you are very lazy, like, okay, we don't want to do this, we don't want to do that. If you are very lazy, for that I have this one thing for you. Just give me a minute. Just one thing here. That is, this is, okay. This is structure of atom PYQs PDF note, right? Okay. If you are very lazy to go through the treasure box, you can directly go through this, okay? If you are very lazy for that. So now this is your structure of PDF note. This is structure of atom notes. This link will be provided to you in the description box after this lecture ends. Right? Okay. This is structure of atom PYQs test, structure of atom NCERT solution. This is your this is your IV SAT registration form. In the IV SAT registration form, what you need to do? You just need to fill down the form here. Right? And register yourself from IV SAT. Yes, bacha. Okay. Is this clear to everyone here? Is this clear to everyone here? Now, I just want one thing from you. That is, do the PYQs test. Do the IV SAT registration. How many of you have done the IV SAT registration? Right? This is check your knowledge as well. Right? Do the IV SAT registration. Then you need to do this PYQs test. PYQs need questions as well and NCERT questions from this chapter. Right? After doing that, just comment down that, ma'am, yes, we have done that, and you will be sorted for this chapter. Right? Okay, notes will be available to you in the Telegram, in the comment section of YouTube, and in the description box as well. Yes, bacha. Okay, then welcome. Bye-bye. Take care. See you all. day after tomorrow, we are going to do thermodynamics, right? We are going to complete thermodynamics. Yes, everyone, ready for that? Perfect. Okay then, bye-bye. See you in the class. Bye-bye.